Welcome to the Windows Server 2022 operating system course, where you will learn the system administration in a simple way. We designed this course for anyone who is interested in system administration. At the end of this course, you will learn how to design, install, troubleshoot, and manage servers effectively. We have designed this course from basic to advanced level, simple way. This course is ideal for the students with zero knowledge. If you are working in the IT networking field and want to enhance your career, then you are at the right place. So guys, first we'll see about course. In this course, you are going to learn Windows Server 2022. So which was released in August 2021. And this course is recommended for the students who want to do the advanced courses like routing and switching, IP telephony, data center, service provider, network security, wireless, virtualization, and cloud computing. So this is a basic course, you can say. So if you want to pursue for the advanced courses, you need to do this course. And let us see the market share of Windows operating system. So Windows client operating system has captured the market around 76.56, whereas Windows Server operating system has captured the market around 30 to 50%. So after completing this course, you will be a system administrator and you will administrate the servers and other end devices like computers, IP phones. And your responsibilities will be, you will install, configure, and manage the servers like DHCP server, DNS server, web server, FTP server, etc. You will create the policies and you will provide the permissions to the users. You will install and configure the software and hardware. You will set up the accounts and workstation for users. You will troubleshoot the issues. You will ensure the security through firewall and antivirus, etc. You will upgrade the systems with new releases and models. And you will monitor the performance and maintain the system according to the requirement. You will back up and restore the data and servers. And virtualization, you will do virtualization and you will do the cloud computing as well. So these will be your roles. So guys, the job opportunities from small to Fortune 500 companies are using the Microsoft products, which required Windows operating system. So job opportunities are huge, but skills are must here. So you should improve the skills. Job opportunities are huge. In this section, we'll discuss the Windows Server 2022 features. The first feature is, it is a 64-bit operating system. So you can see it is a 64-bit operating system. Okay, and if the processor is 32-bit, we can't install Windows Server 2022. So we should have the 64-bit processor to install this Windows Server 2022. And 64-bit operating system is faster than 32-bit operating system because it takes 64-bit input and gives 64-bit output, whereas 32-bit operating system takes 32-bit input and it gives 32-bit output. And it provides the advanced multi-layered security. So the new security capabilities in Windows Server 2022 provides in-depth defense protection against advanced threats. So It is having the capability to fight with the advanced threats. Okay, it is providing the security and advanced multi-layer security in Windows Server 2022 provides the protection that server needs today. So it supports cloud infrastructure as well. So what does it mean? It supports cloud infrastructure. So you can take the backup on cloud. Let us say this is your premises. Okay, premises in the sense the devices installed in your organization, in your company. So this is your premises and you can take the backup on cloud. Okay, from your premises, you can take the backup on cloud and you can install the primary server on your premises. So let us say you have two servers, one primary, one secondary. If primary goes down, secondary will work. So you can install the primary server on premises and secondary server on cloud. So it supports the cloud infrastructure as well. It is having the hybrid capabilities with Azure. So guys, you can manage your Windows, Linux physical servers and virtual machines hosted outside of Azure. Okay, so let us say Azure, it is a cloud service. If you have installed your servers outside of Azure, let us say you are taking the service of other service provider, that also you can manage with this hybrid capabilities. So you can manage your Windows, Linux physical servers and virtual machines hosted outside of Azure or on your corporate network or other cloud provided using Azure Arc services. So this Windows Server 2022, it is having one Azure Arc service. Using this Azure Arc service, you can manage your devices which is outside of Azure. And storage migration service makes it easier to migrate storage to Windows Server or to Azure. So it is having storage migration service as well, which makes it easy to migrate your storage either to Windows Server or to Azure. And guys, it is having improved server manager. What is this server manager? Server manager is used to add services like DNS, DHCP, file server, etc. So this is your server manager. Using this server manager, we can add the multiple services. So it is improved. It has customized dashboard which can be used to add the services on the local server and remote server. So guys, in our previous versions like Windows 2008, we can only install the services on the local server. Let us say you have two servers, S1 and S2. If it is Windows Server 2008, you can only install the services like DNS, DHCP, file server on this local server only. You can't install on the remote server. You need to go to this S2. Okay, you need to log on to S2 server and you need to install it manually. Whereas with Windows Server 2022, you can install the services on the remote server as well. Let us say it is a Windows Server 2022. And if you want to install the services on S2 from S1, you can install it. Okay, so it has improved server manager. It has customized dashboard, which can be used to add the services on local and remote server. And Windows Server can be installed as GUI and CLI based, which means it supports both GUI and CLI operating system. If you want to install your Windows operating system as CLI, you can install it. If you want to install the Windows operating system as GUI, graphical user interface, you can install it. So in this example, you can see here, we have Windows Server 2022 standard evaluation. Here nothing is written, which means if you select this option, it will install the CLI operating system. And in the second option, Windows Server 2022 standard evaluation, desktop experience. Desktop experience means if you select this option, it will install the GUI operating system. So it is having both the options. And it supports Active Directory as well. What is this Active Directory? Is a directory service that runs on Microsoft Windows Server. And the main function of Active Directory is to enable the administrators to manage the permissions and control access to users and other objects. So using Active Directory, we can manage the user permissions and other objects. Let us say, guys, you have some computers. So let us say this is the server where you have installed the Active Directory. It is connected with switch. Switch is connected with some computers. So it is PC1, PC2, PC3, and PC4. You are having 4 computers and there are 4 users. User 1, user 2, user 3, and user 4. So user 1 is using PC1 here. User 2 is using PC2. User 3 is using PC3. User 4 is using PC4. So you need to create the username and password locally to access this PC. So user 1 needs the user account in PC1. So administrator will create the username for user 1 and PC1. So user 1 can log on to PC1. User 2 will log on to PC2. User 3 will log on to PC3. User 4 will log on to PC4. Let us say next day, user 1 wants to log on to PC2. So he can't log in because in PC2, user 1 account is not there. So administrator again, he has to create the username and password on PC2. On next day, user 1 wants to access PC3 again. Administrator has to create the user 1 account in PC3 and PC4 as well. So it was about user 1, and user 2 also wants to access all the computers. So user 2 account should be there in all the computers. User 3 account should be there in all the computers. User 4 account should be there in all the computers. Okay. So administrator has to go to each and every computer and he has to create the 4 username and password. So we have taken the example of only 4 PCs here. Let us say you have hundreds of computers and hundreds of users. So administrator has to go to each and every computer and he has to create the 100 users in all the computers, which is a very tedious task. So instead of that, what you will do, you will install the Active Directory. In this Active Directory, you will create user 1, user 2, user 3, and user 4. If this user 1 wants to access the PC1, this PC1 will check the user account in Active Directory. If it is available, then PC1 allow this user 1 to log on. So again, this user 1 can go to PC2 and he can log on. Okay, he will enter his username and password. Again, you don't need to create the username and password on PCs here. We have already created the username and password on Active Directory. So this PC2 will check the username and password in Active Directory whether user 1 is available or not. If it is available, it will allow this user 1 to, okay, user 1 wants to access PC2, it will allow the user 1 to access PC2. So again, user 1 will go to PC3 again. PC3 will check the Active Directory, it is available, and it will allow. So this is the use of Active Directory. And let us say you want to restrict this user 1 to only 2 PCs. This user 1 can access PC1 and PC2. He can't access PC3, PC4. So we can allow this user, okay, we can create the policy where this user can access only PC1 and PC2. And let us say user 3, you want this user 3 to access only PC3. You can do it from Active Directory from a central point. You don't need to go to the computers to make the settings. So this is the use of Active Directory, and we'll see the Active Directory in great detail. So Active Directory is a directory service that runs on Microsoft Windows Server, and the main function of Active Directory is to enable the administrator to manage the permissions, control access to users and other objects. And this Active Directory has recycle bin feature as well. Using it, deleted accounts and groups can be restored. Let us say you have created some users, user 1, user 2, user 3 and user 4, and you have deleted user 1 and user 2 by mistake. So it will go to recycle bin. From recycle bin, you can restore this user 1 and user 2 in few clicks. The next feature, which is disk quota. So using this disk quota feature, we can limit the users to use the hard disk or storage, you can say. Let us say you have some users like user 1, user 2, user 3, user 4. Okay, and you want user 1 to have only 1 GB hard disk. Okay, you don't want to provide the complete hard disk. User 1 can use only 1 GB hard disk. User 2 can use only 2 GB hard disk. User 3 can use only 1 GB hard disk, and user 4 can use only 500 MB hard disk. Okay, so we can limit the users to use the hard disk using this disk quota feature. And then Windows Server 2022 is having group policy management console as well. What is the use of this group policy management console? It provides the centralized management of user settings. So group policy controls what users cannot do on a computer. Okay, so you will install the Active Directory, and this Active Directory will have this feature GPMC. From this group policy management console, the administrator will control users, what they can do, what they can't do on a computer. For example, we can allow or block the USB and DVD drives for users. Okay, you have multiple computers in your network, and your company policy is that users should not connect the USB drive. So you will go to group policy management console and you will block the USB and DVD drives. Or you can hide the services like control panel, recycle bin on the desktop from a central point using group policy management control. Or if you want to set the same wallpaper on all the devices in your network, so you don't have to go to each and every device and set the same wallpaper. You can do it from a central point within few clicks. And it is having one more feature, backup and recovery. So using this backup feature, you can use Windows Server backup feature to backup a full server. You can take the backup of full server, which means all volumes like CD. Let us say you have multiple volumes on your server, C, D, E. You can take the backup of all the volumes, or you can take the backup of selected volumes. Like you want to take the backup of only C drive, you can do it. Or you can take the backup of a specific file. Let us say you have a file data in C drive. So you can take the backup of this C, you can take the backup of this data folder, file or folder as well. And in case of disaster, you can recover the data as well. So you can use Windows Server recovery feature to recover full server, which means you can recover all the volumes. You can recover the selected volumes. You can recover the specific files or folders in case of disaster. And DNS server as well. So what is this DNS? DNS stands for domain name system. So what is this DNS? It is a phone book of the internet. Okay. When user type the domain name such as google.com or nytimes.com into web browser, DNS is responsible for finding the correct IP for those sites. Let us try to understand what is this DNS. So imagine guys, this is a Google server and the IP address of this Google server is 1.1.1.1. So we can access this server. You will open the browser and you will type the IP address. You will get the website. So using the website, we can access the web servers. But guys, we have millions of websites all over the internet, and it is not possible for us to remember the IP addresses of these websites. So instead of remembering the IP addresses, what you will do, you will assign the name to these IP addresses. You will map the name with the IP address. Like let us say google.com. The IP address of the IP address of google.com is 1.1.1.1. It is mapped here. So you will provide this information to DNS server. Okay, DNS server will map google.com with 1.1.1.1. Now you want to access this Google website using the URL, using the name. So you will open the web browser and you will type google.com. So your request will not directly go to google.com. Your request will go to the DNS server. DNS server will check what is the IP address of this google.com. The IP address is 1.1.1.1. Then this DNS server will provide the IP address to your host 1.1.1.1. Then this host will access this server using this IP address. Okay. Windows Server operating system is having one more feature called IIS, which stands for Internet Information Services. IIS for Windows Server is a flexible, secure, manageable web server for hosting anything on web, from media streaming to web applications. So guys, IIS is a web server for Windows environment. What is web server? If you want to host any website like Microsoft.com, YouTube.com, we need a web server. In Windows environment, we have IIS. We will install IIS on a Windows machine. Then we will host the website. We can host a video website or any web application. It supports different protocols like HTTP, HTTPS, and FTP. Then it supports virtualization as well. So guys, virtualization is a technique that allows a physical machine to run multiple operating systems on a single physical system simultaneously by sharing its hardware. So guys, previously in olden days, we used to have a physical server. On this physical server, we used to install the operating system like Windows Server. On the top of this operating system, you will install the application. Let us say you have 10 applications. So you need 10 physical servers to install these 10 applications. The ratio is 1:1. If you have 100 applications, you need 100 servers. So virtualization has solved this problem. You don't need multiple physical server for multiple applications. What you will do, you will take one physical server and you will install a virtualization software. On the top of this virtualization software, you will create multiple virtual servers here. In this example, you can see we have created 1, 2, 3, 4, 5, 6 virtual machine. On the top of these 6 virtual machines, we have installed the operating systems, and it is having one more feature called Windows Deployment Service. What is the use of this WDS, Windows Deployment Service? It allows an administrator to remotely deploy and install the Windows operating system on computer booting from the network. So guys, let us say you have 100 PCs and you want to, these are the new PCs, and you want to install the Windows 10 operating system on all these 100 computers. So you will have to go to each and every computer and you will install the operating system one by one, and it will take a lot of time. So let us say one PC takes 30 minutes. Okay, so each computer will take 30 minutes, and around 3000 minutes you have to spend in installing the operating system on all the computers. So what this WDS will do, when you connect any PC, this is a WDS server. So when you connect any PC, this WDS will install the operating system on all the computers automatically. Okay, so it allows administrator to remotely deploy, install the Windows operating system on computers booting from the network adapter, and which saves your time. So it is having one more feature, DHCP. DHCP stands for Dynamic Host Configuration Protocol. Okay, so it is a network management protocol used on internet protocol, which is IP networks, for automatically assigning the IP address and other communication parameters to device connected to the network using client server architecture. So guys, let us say you have some computers, you have hundreds of computers in your network. You have connected all these devices to a network, and we need to provide the IP address to all the computers. Okay, so you need to go to each and every computer and you will configure the IP address like 172 dot, you are using 172.27.100.0 network. So you will go to each and every computer and you will type 172.27.100.21, 100.22, 100.23, 100.24, and so on. So guys, it will take a lot of time and you may make mistakes as well. So instead of configuring the IP addresses manually on all the computers, what you will do, you will configure the DHCP server, and you will configure this DHCP server, or you will train this DHCP server. You will tell that you should provide the IP addresses to the computers from 172.27.0.100.0 network, and the subnet mask will be 255.255.0.0, and let us say the gateway is 172.27.100.1, and you have the DNS server as well. So 172.27.100.50, let us say this is the DNS server IP address. So you will train this DHCP server to provide the IP addresses to the clients. What is computer? Computer is an electronic device that takes input from the user and process it, and it gives you the output. Okay, so this is the definition of computer. We'll see what is computer in detail in our coming slide.
Guys, let us try to understand computer in detail. So computer is an electronic device that takes input, then process it, then gives you the output. So it takes input from input device like keyboard. Okay, this is the keyboard, and it is also called as input device. And processing is done by CPU, and it is the brain of the computer. Okay, this is the CPU. Okay, this is the chip, the processor is called as CPU, and it is the brain of the computer. So guys, most of the students, they think that this box is the CPU. It is not a CPU, it is a cabinet. Okay, and then it gives the output to the output device like monitor. So guys, it is like when let us say I ask you what is 2 plus 2. Okay, you heard my question from your ear. So your ear is your input device. Then you calculate what is 2 plus 2 on your mind. So your mind is your process. So, and when you calculate it, which means you are processing what is 2 plus 2. And you tell the answer 4. Okay, so mouth is your output device. The same way, the keyboard, you type 2 plus 2 on keyboard. This is your input device. Then it will process this processor. Okay, it is installed in this cabinet. Okay, CPU cabinet you can say, and it will process what is 2 plus 2. After processing it, it will give you the output what is 4. So monitor is your output device. So computer is an electronic device that takes input, then process it, then gives the output. It takes the input from input device like keyboard, and processing is done by CPU, and CPU is the brain of computer, then gives you the output to the output device like monitor. So it stores, this computer stores the data for further processing, and computers understand only the binary numbers, zeros and ones. They don't understand our normal language, they don't understand English. So when you give any command to computer, it will be converted to binary numbers. Okay, and computers required power supply to DC power supply to work. Let's try to understand the architecture of computer. Okay, so let us say you want to calculate what is 2 plus 2. So you will give the input using keyboard. Then it will not directly go to the processor, it will go to the memory. Memory means RAM. It will go to memory. From this memory, this CPU will fetch the information. CPU is having two parts. One is control unit, the other one is arithmetic logic unit. So this control unit will fetch the information from memory, and this information will be provided to ALU to do the calculations. This ALU will do the calculation, what is 2 plus 2, 4. Then it will provide the information to memory. Okay, memory will provide this information to the output device. So this is the architecture of computer. If you see here, we are giving input to the through this keyboard 20 plus 20, then it will go to memory. Memory is nothing but your RAM. From RAM, CU will take the information and it will provide to ALU. ALU do the calculation and it will provide the answer to CU. CU will send the answer to this memory. Memory will send the answer to the output device port. We will see who is the father of computer. Charles Babbage originated the concept of a digital programmable computer. So he is Charles Babbage, and Babbage is considered by some to be a father of computer. So some people call him father of computer. And Babbage is credited with inventing the first mechanical computer. This is the first mechanical computer which is developed by Charles Babbage. All the essential ideas of modern computers are to be found in Babbage's analytical engine. So let us see what is the first generation computer. ENIAC was the first computer and it was launched in 1945. Okay guys, so this is the ENIAC computer. This is the first computer. This is the first generation computer which was launched in 1945, and it was designed using 18,000 vacuum tubes. Okay, so it took 18,000 vacuum tubes to develop this computer, ENIAC computer, and these are the vacuum tubes. Okay, with the help of these vacuum tubes, this computer was developed. So the weight of this computer is around 25,000 kilograms. The exact weight is 24,493 kilograms. It was very heavy, and this ENIAC stands for Electronic Numerical Integrator and Computer. So, and guys, let us discuss about the second generation computer. A second generation computer was developed using transistors. Okay, these are the transistors, and this is the second generation computer, and it is developed by using these transistors. And the full version commissioned in April 1955, and it was also called as transistor computer. Third generation computer. The third generation computers use the ICs or integrated circuits. So this is the integrated circuits. This is used in the third generation computer. Computers primarily using ICs first came into use about 1961 for military use of computer. And guys, fourth generation computer was launched in 1971, and the fourth generation computer comes with microprocessor, and nowadays we call it as CPU. Okay, so we use the microprocessors in fourth generation computer, and this fourth generation computer uses VLSI technology. VLSI stands for very large scale integration technology, and VLSI with VLSI up to 1 million transistors can be added to the processor. Okay, so we can add up to 1 million transistors, guys. So this processor, if you see, it is having multiple transistors. Okay, up to 1 million transistors we can add. Fifth generation computer, it was launched in 1989. It also uses the microprocessors. From the fourth generation computer, we use the microprocessors or CPUs. And this fifth generation computer uses ULSI technology, ultra large scale integration technology. With ULSI, we can add more than 1 million transistors to the processor. Okay, and it supports artificial intelligence as well. Now, guys, we have a mainframe computer also. Okay, let us try to understand what is this mainframe computer. Mainframe computer is a computer used primarily by large organizations for critical applications and bulk data processing. This is the picture of mainframe computer. Okay, the first mainframe computer was the Howard Mark I. Okay, this is the name of the first mainframe computer which was developed in 1943. And IBM has developed its first mainframe computer in 1952. Okay, this is the first IBM mainframe computer which was developed in 1952. World's first personal computer. Kenback 1 is the world's first personal computer as per Computer History Museum and the American Computer Museum. It was invented by John V.K. Blankenbaker in 1970. It was first sold in 1971 and discontinued in 1973.
IBM first personal computer. IBM had released its first personal computer model 5150 in 1981. It is commonly known as IBM PC.
Operating system for IBM PC. Microsoft had developed the operating system for IBM PC. The operating system was MS-DOS. MS-DOS is a command line operating system. MS-DOS stands for Microsoft Disk Operating System.
In this section, we will discuss about computer components. Computer is having multiple components like input device, output device, processor, motherboard, primary storage, secondary storage, SMPS. So we'll discuss about these components one by one in detail. We'll see input device. So we have different input devices like keyboard and mouse. A keyboard is an input device that allows a person to enter letters, numbers, and other symbols together, and these are called as characters. Okay, these are the characters or keys you can say into a computer. And mouse, a computer mouse is an input device that is used with a computer. So this is the mouse which is used with a computer. Let us see what is output device. So we have monitor. This is the monitor and it is a output device. A computer monitor is an output device that displays the information in pictorial form. So you will get the information in pictorial form on your output device on your monitor. Then we have one more component which is called as processor. So this is the processor which is also called as CPU. Guys, this is not a processor. It is a CPU cabinet, you can say, where you will install the motherboard. This is the motherboard. On this motherboard, you will install the CPU or processor. So a processor is also called a central processor, main processor, central processing unit or CPU is the electronic circuit that performs basic arithmetic logic controlling input-output operations, and it is the brain of the computer. So processor is the brain of computer. So while purchasing the processor, while selecting the processor, we need to check the processor specifications. So while selecting the processor, we must consider the following specification or features of the processor. We need to check the speed of processor. We need to check the width of processor. We need to check the FSB, front side bus speed. We need to check the cache memory. We need to check whether the processor supports virtualization or not. We need to select the course and we need to select the generation as well. We'll discuss about these specifications one by one. First, we need to see the speed. So processor's speed is measured in hertz, megahertz, and gigahertz. And what is hertz here? It is a unit of frequency of 1 cycle per second. You can see this is 1 cycle per second. So it is called as hertz here. And what is megahertz? 1 million hertz makes 1 megahertz and 1000 megahertz makes 1 gigahertz. So latest processors speed is measured in gigahertz. Example 1.4 gigahertz, 2.40 gigahertz, 4.3 gigahertz, etc. Let us check what is the speed of my computer. How to verify? You will go to this PC, right click, more, properties, and you will get the speed here in the processor section. The speed is 4.2.40 gigahertz. So this what is width here. The CPU width is the architecture of CPU is measured in bit. For example, 32-bit processor, 62-bit processor. 32-bit processor supports 32-bit operating system and software. So if you have a 32-bit processor, you can install only 32-bit operating system. You can install only 32-bit softwares. If you have 64-bit processor, which means you can install 64-bit operating system, you can install 64-bit software as well. And you may get the hybrid processor as well, which support 64-bit and 32-bit operating system and softwares. Okay, so hybrid processor supports both 32-bit and 64-bit software. Let us see the difference between 32-bit and 64-bit processor. This 32-bit processor is a type of CPU. 32-bit is a type of CPU architecture that is capable of transferring 32 bits of data per clock cycle. Whereas 64-bit is a type of CPU architecture that is capable of transferring 64 bits of data per cycle. So 64-bit processor is faster than 32-bit processor, and it requires more time to process and response. It is slower than 64-bit processor, requires minimum time to process and response, and it can address memory up to 4 GB of RAM, which means 32-bit processors supports maximum 4 GB of RAM, whereas 64-bit processor, they support 16 exabyte of RAM, guys. It is exabytes, not gigabytes or GB. 1 exabyte is equal to 1 million TB. Okay, and this 32-bit processors are cheaper, whereas 64-bit processor, they are very expensive. And we need to check the FSB speed as well. FSB stands for front side bus. So what is this FSB? Let us try to understand. It is a track from RAM to processor and processor to RAM. So in this example, if you see, we are giving the input here. The input will go to the memory. From the memory, CPU will fetch the information. So they have one track between CPU and memory, and that track is called as FSB. So this is the back side of the motherboard. This is the processor, okay, and let us say this is the RAM, and the track between processor and RAM is called as FSB. So from this track, data flows between RAM and processor. So we need to check the speed of FSB. So FSB speed is measured in megahertz, and you will find the FSB speed like 333 megahertz, 800 megahertz, 1066 megahertz, 1600 megahertz, 20,000, so 2666 megahertz. So guys, let us say your processor supports 2666 megahertz, but your RAM FSB speed is 1600 megahertz. So you will get maximum 1600 megahertz of speed. So you need to check the speed of processor, and you should check the speed of RAM as well. Then we need to check the cache memory of your processor. What is this cache memory? It is a temporary memory which stores the frequently used data. So this is your CPU and this is your RAM. Let us say you are opening Notepad frequently. So what this CPU will do, it will request the Notepad to your RAM. So if you are opening the Notepad 100 times, this CPU has to request the Notepad to RAM 100 times, which will take a lot of time. So what this cache memory will do, it will save, okay? This is the cache memory, and it will save the most frequently used files. Okay, when the CPU needs Notepad, it will take the Notepad from the cache itself. Okay, so it is a temporary memory which stores the frequently used data. It lets CPU to access the information faster than if it is accessing from RAM. So it is faster than RAM. Okay, and cache is 100 times faster than RAM. Cache storage is limited, but it is very expensive. It is very limited, guys, and it is very expensive as well. And it is measured in kilobytes and megabytes. So there are 3 cache levels that describe the chip's closeness to the processor. If you see here, we have 3 cache levels: level 1 cache, level 2 cache, level 3 cache. So, and level 1 cache, this cache, it is a primary cache, and it is extremely faster, and it is small and usually embedded in CPU. So this level 1 cache, it is embedded with CPU itself as a CPU cache. Then we have this cache, level 2 cache, and level 2 cache or secondary cache usually holds more data than L1 cache. So it holds more data than L1, but it is slower than L1. It can be embedded on CPU or it can be a separate chip. So this level 2 cache, it can be embedded to CPU or it is a separate chip between CPU and memory. And we have L3 cache, and L3 cache is significantly slower than L1 and L2, but it is faster than RAM. So this L3, it is having more space than L1 and L2. It is slower than L1 and L2, but it is faster than your RAM. How to verify the L1, L2, and L3 cache? So what you will do, you will right click, then you will go to Task Manager. Under Task Manager, you will see the cache here. L1 cache 128 KB, L2 cache 512 KB, L3 cache 3 MB. You can see the size of L3 cache is 3 MB. Okay, it is larger than L1 and L2, but it is slower than L1 and L2. So this is the processor, and if you see this processor, on this processor, it is written like 3.116 gigahertz, 12M, and 1333. So 16 gigahertz is the speed, 12M is your cache, and 1333 is the speed in megahertz of your FSB. Then we need to check whether your processor supports the virtualization or not. Okay, guys, what is virtualization? It is a technique that allows a physical machine to run multiple operating systems on single system simultaneously while sharing its hardware. So virtualization, what it will do, it will allow a physical machine to run multiple operating system. But how will you run multiple operating system? How will you perform the virtualization on any computer? Your CPU should support virtualization. If your CPU is not supporting virtualization, you can't run the multiple operating system on the same machine. So if virtualization is supported by CPU, we can perform virtualization. And when you are purchasing Intel CPU, Intel calls it as Intel VT, virtualization technology, and AMD calls it as AMD V. Okay, so if it supports virtualization, let us say you have purchased a CPU which supports virtualization, but we need to enable it. Okay, virtualization technology should be enabled on your computer. So we will do virtualization for our lab. So we are going to perform the virtualization for our labs. And how to verify whether the CPU is supporting the virtualization or not, whether the virtualization is enabled or not. Again, you will right click, then you select this task manager, then you will go to performance. Under performance, you will see virtualization is enabled here. Okay, it is supporting virtualization and virtualization is enabled. So most of the latest CPUs, they support virtualization. Okay. Okay. Now guys, we need to check the core. You might have heard this terminology called core. Okay. My CPU is quad core, octa core, deca core, etc. So let us try to understand what is this core. A CPU core is CPU's chip. You can see this is the CPU. On this CPU, one chip is embedded. This chip is called as core. And in olden days, every processor had just one core and that could focus on one task at a time. So let us say you have multiple tasks. You want to play some video, you want to open one application, you want to play the audio as well. So this one core has to process all the tasks. So what it will do, it will process one task. Let us say it will process the video first. After processing the video, it will process the files, then it will process the audio. So it will make the system very slow. So in olden days, every processor had just one core that could focus on one task at a time. And today's CPU have more than one core, each of which can perform different tasks. You can see this is the CPU. On the CPU, we have two cores. So one core, it will deal with the videos, the other core will deal with the files. Okay, the task is divided here and it will make the process very faster. So guys, PC support up to 10 cores. PCs can have 10 chips on the processor and servers support up to 32 cores. And it is very expensive and you will get good performance if you have more cores. So as we have discussed, PC support 8 to 10 cores and server supports up to 32 cores. You can see this course and it is very expensive, but you will get the good performance. So I think this slide is repeated. And let us try to understand what is the meaning of dual core. Dual core means two cores, which means you are giving the one task to two persons and these two persons will perform the same task, which will make your process very fast. Quad core means 4 cores. You are providing the task to 4 people here. And octa-core means 8 cores. Deca-core means 10 cores. And we have a concept called hyper-threading. What is this hyper-threading? Hyper-threading is a process by which CPU divides up a physical cores into virtual cores. So you will have one chip, okay, and this is the physical core. What the CPU will do, it will divide one task into virtual cores. Let us say you want to execute one file. So these two cores will divide the task and they will execute this file together. Okay. So it is hyperthreading is a process by which CPU divides up its physical cores into virtual cores that are treated as they are actually physical cores by the operating system. So operating system will consider these virtual cores as physical cores. And deca cores means 10 cores. And guys, we have a concept called core i3. You might have heard this concept. What is the meaning of i3 here? Okay, i3 means it is a dual core. It is having 2 cores and it supports hyper threading. So this chip is having, the processor is having 2 cores or 2 chips, and it supports the hyper threading as well, which means it will have the 2 virtual cores, which makes it quad core. You will get 4 cores here in i3. Then we have i5. Okay. So what is this i5? If you are purchasing the laptop, you will get the dual core and it supports hyper threading and you will get quad core. If you are purchasing the processor for desktop, you will get the quad core, which means you will get the 4 physical chips. Then we have i7. If you are purchasing the laptop, you will get dual core or quad core. Plus you will get the hyper threading. Whereas you are purchasing the processor, i7 processor for desktop, you can get quad core or octa core with hyper threading. Then guys, we need to check the generation as well. So you might have heard that this CPU is 10th generation CPU. This CPU is 7th generation CPU. Let us try to understand how this generation is calculated. This generation is based on the transistor, size of the transistor. Okay, so small transistors means the latest generation. So when the companies reduces the size of the transistor on CPU, the generation changes. Okay, so small transistors saves the battery or power, and previously we had 28 nanometer transistors. Nowadays it is 14 nanometer transistor. So the size of the transistor decides the generation. It has nothing to do with the performance of your computer. It is okay, it is for the saving the power or battery. Okay, so how will you identify the generation of your CPU if it is installed on your computer? Okay, you will right click this PC, and if you see this pi here, which means it is a 5th generation processor. Let me show you. So this is the processor, and here if you see, I have 7th generation processor. Who manufactures this processor? So we have so many manufacturers, but the famous manufacturers of processors are Intel and AMD. AMD stands for Advanced Micro Devices, and they manufacture the client and server processors. Client processor, client means the processor which are used for PCs. Okay, so the client processors, if you are purchasing Intel processor, you will get like Core i3, Core i7, Core i5. If you are purchasing the AMD processor, you will get Ryzen processor. These processors are used to install on PCs. Then we have server processors. So if you are purchasing the Intel processor for server, Intel calls it as Xeon processor, whereas AMD calls it as Opteron processor. So these two processors, Xeon and Opteron processors, are for servers. In this section, we will discuss about motherboard. So a motherboard is also called as mainboard. This is a motherboard. Okay, and it is also called as mainboard. And it is a circuit board where we connect the other components like CPU. Okay, we connect the CPU here. RAM, we connect the RAM here. Hard disk. Okay, so we have some sockets here to connect the hard disk, and we connect the keyboard here, mouse, LAN card, etc. So it is used to connect the computer components. So it allows the communication between components like CPU, RAM, hard disk, keyboard, mouse, LAN card, etc. So this motherboard allows the communication between the computer components. You will connect all the components to the motherboard, and it will allow, excuse me, and it will allow the communication. So there are two types of motherboards. One is client motherboard, which is used for PCs, and we have server motherboard, which is used for servers. So client motherboard, it has, if you see, this is the example of client motherboard. And if you observe here, we have only one socket to connect the CPU, which means we can connect only one CPU here. We can connect only one processor. So it has one processor socket. We can't run this device 24/7. Okay. And it is not suitable for servers. It is suitable for PCs. We can't run the computers 24/7 with this motherboard. Let us see the server motherboard type 1. So in server motherboard also we have two types. So this is type 1 server, which is having 4 processor sockets. You can see here, we can connect 4 processors to this motherboard. And each socket will have 8 RAMs, 1, 2, 3, 4, 5, 6, 7, 8. And we can run heavy applications like Oracle and SAP. We can do the multitasking, and we can run the devices 24/7. It is having 4 processor. It is having multiple sockets for RAMs. Okay, so we can run this server 24/7. And we have server motherboard type 2. And if you see here, it is having 2 sockets to connect the CPUs. We can connect 2 CPUs, 2 processors to this motherboard. And it is useful for limited hours only. We can't use the computer which is having this motherboard for 24/7. So let us say your organization runs, okay, only for 12 hours. So you should go for this motherboard. In this section, we will discuss about one more computer component, which is storage. So storage is used to store the data. There are two types of storage, primary and secondary. What is primary storage? The storage is provided by memory in a computer system. So the storage which you will get using by RAM or ROM, it is called as primary storage. And what is secondary storage? The storage is provided by peripheral devices other than RAM and ROM. So the storage which you get other than RAM and ROM, like hard disk drive, USB drive, they are called as secondary storage. So as we have discussed, the primary storage, we have two types, RAM and ROM. So let us discuss the difference between RAM and ROM. So with RAM, if you see the data retention, RAM is a volatile memory which could store the data as long as the power is supplied. So it is a volatile memory. Volatile memory means it will save the data temporarily. When the power is off, the data will be deleted from RAM. Okay, that is why it is called as volatile memory. Whereas ROM is a non-volatile memory which could retain the data even when the power is turned off. So even after the power is off, the data in ROM it will be saved. And the working type data stored in RAM can be retrieved and altered. So the data which is stored in RAM, we can retrieve and we can change the data. Whereas the data which is stored in ROM can only be read. So we can read the data in ROM. And what is the use of RAM? It is used to store the data that has to be currently processed by CPU. So that it will have the data which should be processed by CPU. Whereas it stores the data instruction required during the bootstrap of computer. So it has the data which required during the boot up, okay, power on the computer. And the speed, it is faster than ROM, and ROM is very slower. And CPU, the CPU can access the data stored in it. So whatever the data is stored in RAM, it can be accessed by CPU. Whereas whatever the data is stored on ROM, it can't be accessed by CPU. We have different types of RAM available. RAM is available in different types. Example DDR, DDR2, DDR3, and DDR4. So this DDR version, like DDR2, DDR3, DDR4, this DDR version depends on the size of chip size. Okay, if you see here, we have multiple RAMs: DDR, DDR2, DDR3, DDR4, and each RAM is having the chip. So DDR is having the bigger chips. DDR2 is having smaller than DDR. DDR3 having the chips which are smaller than DDR2. DDR4, these chips are smaller than DDR3. So this version depends on the chip size. So DDR2 has bigger chip. This DDR2, it is having the bigger chips than DDR3, whereas it is smaller than DDR1. And DDR4 has smallest chip. You can see here. And this DDR4 is faster than all the versions and it consumes less power. Okay, so DDR1 RAM has 184 pins. If you see these pins, it is having 184 pins which consumes 2.5 volts of electricity. Whereas DDR2 RAM has 240 pins and it consumes 1.8 volts of electricity. DDR3 RAM has 240 pins which consumes 1.5 volts. DDR4 RAM has 288 pins and it consumes 1.2 volts. So different RAM type has notch at different place. So guys, if you observe here, the notch, this is called as notch. So this DDR1, DDR2, DDR3, DDR4, they have notch at different places. Let me take you back. if you see here, DDR is having the notch here, DDR2 is having the notch here, DDR3 it is having the notch here, whereas DDR4 is having the notch here. Okay, so each RAM has notch at different place. All RAM types can't be installed on the same slot. So you can see it is having the notch at different place, and you can't install all the RAMs on the same slot. Slot should be compatible with RAM. So it was about the primary storage. Let us discuss about the secondary storage. So we have some examples of secondary storage like magnetic storage device. Under this magnetic storage device, we have hard disk, tape drive. Then we have optical storage devices like CD, DVD, BRD. Then we have flash storage devices like pen drive, memory card, and SSD. These are the examples of secondary storage. Let us discuss about the hard disk. So hard disk, this is the picture of hard disk, and it saves the data permanently, unlike RAM. So if you power off the computer, the data will be there. It will not be deleted. And it stores the operating system as well. It stores the data and it stores the operating system as well. And the storage capacity of this hard disk is 5 TB plus. Okay, you can see this hard disk is having the capacity of 10 TB. Then we have tape drive under this magnetic storage. This is the tape drive. It is used for backup, and the storage capacity is up to 580 TB of this tape drive. So they are used for backup. And under this optical storage, in the optical storage devices, all read and read activities are performed by lab. So these are the examples of optical storage. And in optical storage, the data is read and read by the light. And we have the example of this optical storage like CD, DVD, and Blu-ray. CD stands for compact disc, and the storage capacity is 700 MB. DVD stands for digital versatile disk, and the storage capacity is from 4.7 GB to 8.5 GB. BRD stands for Blu-ray disc, and the storage capacity is from 25 GB to 50 GB. These are the optical storage, which comes under the secondary storage. Then we have flash storage. This flash storage is a solid state technology. What is solid state technology? It uses the flash memory chip. This technology uses the flash memory chip to save the data. Okay, for writing and storing the data, it uses the flash memory chip. It is called as solid state technology, and flash storage is very fast. So USB flash drive, memory cards, SSD drives are the examples of flash storage. These are the examples of flash storage, which means they use the flash storage technology, solid storage technology. So this USB flash drive stores the data up to from 4 GB to 2 TB. And these memory cards, the storage capacity is from 2 GB to 256 GB and more. And we have SSD as well, which stands for solid state drive. This solid state drive also uses the flash memory to save the data. If you open this SSD, you will find the flash memory. You will find the chips here to store the data. So it also functions as secondary storage in the hierarchy of computer storage. So this SSD is also a secondary storage like HDD, hard disk drive. So guys, let us see the difference between hard disk drive and SSD. We'll see the difference between HDD and SSD. Okay, it is SSD. And the first difference is HDD is a 50 years old technology. It is a very old technology, whereas SSD is a new technology. HDD has movable parts like platter, makes it delicate. So this is the HDD. Okay, if you open, it looks like this, and it has the platter, and it will save the data on this platter. Okay, and it is having the movable parts, you can see, and the data is read by this needle. So these parts are movable, which makes hard disk drive very delicate. Okay, and the data is saved on platter and it is read by needle. Whereas SSD has no moving parts. It has memory chips to save the data, and it is very durable as well. And this HDD, it is very cheap, whereas SSD, it is very expensive when compared to HDD. And the size of this HDD is big, whereas the size of this SSD is small. And HDD is slower than SSD. Okay, it is very slow, whereas SSD is very fast. And we have one more computer component which is called as SMPS. SMPS stands for switch mode power supply. Okay, so when you open the computer, you will find this box. This is your SMPS, and it is used to supply the power to the computer. It will supply the power to the components of your computer, and it provides DC voltage to all system components, and it is having a fan. So power supply fan is used to keep SMPS fresh. So it will make the SMPS fresh. So these are the computer components.
So guys, we'll see what is network and networking. So as a system administrator, our responsibility is to manage the client and servers, okay, connected to the network. So what is this network? Let us try to understand. Network, it is an interconnection of two or more devices to share the information and resources. For example, files and printers. So in this example, we have 6 computers, 1, 2, 3, 4, 5, 6, 6 PCs, and one server is there and one printer is there. Okay, and these devices are connected in a network, and let us say this server is having some files. Okay, and PC1, PC2, PC3, PC4, PC5, and PC6, if they want these files, they can access these files from server. Okay, if they are connected to network. If they are not connected to the network, let us try to understand what will happen. So imagine we have 4 computers. PC1, PC2, PC3 and PC4. And these 4 computers are standalone, which means they are not connected to network. PC1 is having some files, and PC2, PC3, PC4, they need these files. So what they will do, users which are using these PCs, they will have the external storage, okay, like external hard disk or external USB. They will take this external storage to this PC1, they will connect it to PC1 and they will copy and paste the files to the external storage, and again they will connect this external storage to their PCs and they will copy the files from external storage to their PCs. Okay, so again the same thing is done by PC3 and PC4 as well. So here we are taking the example of only 4 computers. In real networks we have hundreds of computers. So imagine if all the 100 computers they need these files, what will happen? Okay, so all these users, they will come to this PC and they will connect their external devices to this PC and they will copy and paste the files, and again they will connect this external device to their computers and they will copy and paste the files. So it will take a lot of time, okay, and it will disturb this PC1 as well. So what you will do, you will connect these computers in a network and these PCs can access these files, okay, or users which are using these PCs can access these files by sitting on their PCs. They don't need to go to the computer, to this PC1. Okay, this is the first problem if you don't have any network. And let us say this PC1 is having printer connected. Again, this PC1 can print the document very easily because it is this printer is connected to PC1. But PC2, PC3, PC4, if they want to print the documents, so what you need to do, you will need to take this printer from PC1 and you will connect this printer to PC2, then PC3, then PC4. Again, we have only 4 computers in this example. In real time, in real network, we have hundreds of computers. Okay, it will be very difficult for you to take this printer and connect it to all the hundreds of devices. So what is the first solution? The first solution is you need to purchase the printer for each and every computer. Okay, if you have hundreds of computers, you will connect the printer for each and every computer. Okay, you need to spend a lot. So instead of purchasing the printer for each and every computer, again you will connect these computers to a network. These computers will be connected to the network and you will connect this printer to the network. Okay, and PC1, PC2, PC3, PC4, they all can print, okay, from the network. They don't need to connect this printer to their computers. Okay, so this is the advantage of connecting the devices into a network. So network is a interconnection of 2 or more devices to share the information. Information is nothing but the sharing the files, and the resources. Resources nothing but your printer. And what is networking? Networking, communication of 2 devices in the network is called as networking. If you make the communication between 2 devices in the network, it is called as networking. So guys, we have different types of network. We have LAN, which stands for local area network. We have MAN, metropolitan area network. We have WAN, wide area network. PAN, personal area network, and we have CAN, campus area network. So let us discuss about different types of networks one by one in detail. We'll see what is LAN first. Is a collection of devices connected together in one physical location, such as office or building. So in LAN, what you will do, you will connect the devices, you will form your network on one location. Okay, as the name suggests, local area network, which means you are going to connect the devices locally. You are going to connect the devices on one place. It can be a small office with 10 to 15 computers, or it can be a building with 100 to 500 computers. But the condition to form a LAN, they should be in the same location. So in this example, we have 6 computers, 1 printer, 1 server. They are all connected in the same location and they are forming the LAN here, local area network. Okay, so remember one point, devices should be connected in the same location. Then it is called as local area network or LAN. Then we have MAN. Then we have MAN. MAN stands for Metropolitan Area Network. So as the name suggests, metropolitan, it is talking about the city limits here. So guys, imagine you have 2 LANs in the same city. Here you have 2 computers here. Let us take the example of 2 computers. And these 2 computers are connected with switch. And they are forming one LAN. Let us say it is LAN 1 in Hyderabad. You have one more branch office in Hyderabad. Okay, this is the head office, and let us say there is a branch office as well. In the branch office also you have a LAN. Let us say it is LAN 2. Okay, so when you connect the LANs in the same city, it is called as metropolitan area network. So in this example, if you see here, we have LAN 1, LAN 2, LAN 3, LAN 4. All these LANs are there in the same city. Let us say it is Hyderabad, and they are connected with each other and they are forming the MAN here, metropolitan area network. Okay, so MAN is the interconnection of 2 or more LANs in the same city, and the range is from 50 to 100 kilometers of metropolitan area network. Then we have one more network which is called as WAN, and which stands for wide area network. So wide area network is a collection of local area networks over a great geographical distance. So let us try to understand what is this WAN here. So guys, in this example, we have one Hyderabad LAN with 3 computers, 1 server and 1 IP phone. They are all connected in a LAN here. Okay, so this is your Hyderabad LAN. And we have one more LAN in Bangalore with 3 computers, 1 IP phone and 1 server. Also, these devices are also connected in the same location and they are forming the Bangalore LAN. And our requirement is to make the communication between these 2 different LANs, okay, which are very far from each other. So what you will do, you will connect these 2 different LANs using the WAN link. Okay, so WAN is a collection of local area networks over a great geographical distance. A WAN is essentially a network of networks, okay, and with the internet, the world's largest WAN. So internet is also an example of WAN, okay, but internet is a public WAN and anyone can connect to the internet, okay, and internet is a network. It is a big network of a smaller network. So what is the definition of internet? It is a network of networks. Okay. Then we have one more network which is called as personal area network or PAN. So PAN is a computer network for interconnecting the electronic devices within an individual personal workspace. So PAN is nothing but the connectivity of your personal devices. Okay, if you connect your personal devices, it is called as personal area network. and the range of this span is 10-meter maximum, okay, where you will connect your personal devices like smartphone, tablets, laptop, desktop, headphones, printers, okay, within the range of 10 meters. So it involves the computer, phone, tablet, printer, PDA, speakers, video game consoles, etc. Okay, so this span can be wireless or wired. In our previous sections, we have discussed what is network, what is networking. We have discussed about different types of networks. In this section, we will see the requirements to set up a network. So we need end devices like PCs, servers, printers, IP phones, etc. We need media, guided media, unguided media. We'll see what is this media in our coming videos. We need network interface card. We need network devices like switches, routers, firewalls, access points, etc. We will discuss about these different network devices in detail in our coming videos. And we need IP address and we need operating system to set up a network. What is end device? It is a source or destination device in the network. For example, PC, printer, IP phone, or server. So these are the examples of end devices. And guys, we have one more network which is called as CAN. A CAN is a computer network made up of an interconnection of local area networks which are fairly close to each other in multiple buildings. So guys, you might have visited any university. So in universities, you will see multiple buildings which are fairly close to each other. Okay, these are the buildings which are fairly close to each other, and each building is having LAN. And this campus area network connects all these LANs. Okay, so a CAN is a computer network made up of an interconnection of local area networks which are fairly close to each other in multiple buildings. So CAN is larger than LAN but smaller than MAN, which covers the area up to 5 kilometers. It is also called as campus network and corporate area network. It is typically seen in universities and corporates. So in this example, if you see, we have an academic building. This academic building is connected with building 1, building 2, building 3, which are fairly close to each other. It is connected with a hostel zone and residential zone. So students sitting in the hostel zone, they can access the library, and students sitting in the residential zone, they can access the library and they can access the internet as well. Okay, so we'll see what is media. Media refers to a communication channel which connects the devices in the network and transmit the data from source to destination. There are two types of media, guided media and unguided media. What is guided media? It is also referred as wired media. This guided media is referred as wired media, where we use the cables and signals are transmitted using physical link, which provides a high speed and it is very secured as well. So these guided media or cables, they provide the high speed and they are very secured as well. We have some examples of guided media like coaxial cable, UTP cable, fiber optic cable. So this is the coaxial cable. Okay, you might have seen this coaxial cable to connect the television, and we have UTP cable. Okay, this is the UTP cable. Okay, which is used in LAN. This is also an example of UTP cable. Then we have fiber optic cable. This is the fiber optic cable. Okay, so this coaxial cable, this cable used for connecting the TVs with maximum distance 500 meters. So you will use this cable with maximum 500 meters. If your distance is more than 500 meters, it will start dropping the signal. Then UTP cable, it is used in LAN with maximum distance of 100 meters. So let us say you have some computers and you want to connect these computers to a LAN. So you need a switch. Okay, and to connect these computers to switch, you will use this UTP cable. Okay, this cable is used to connect the devices in a LAN and the distance is maximum 100 meters. If you are selecting the cable more than 100 meters, it will start dropping the signal. And we have fiber optic cable. This is the example of fiber optic cable, and it is used in WAN with maximum distance of 100 kilometers. So we have two different sites here. One site is in Hyderabad, the other side is in Bangalore. And you want to connect these two different sites, you will use this fiber optic cable. Okay, it is used in WAN. Then we have
unguided media. Unguided transmission media are methods that allow the transmission of data without the use of cable. Okay, so you have some wireless devices like wireless station 1, wireless station 2, wireless station 3, wireless station 4, and you want to make the communication between these wireless devices, you will use the RF signals. Okay, you will have an access point. Using this access point, you will connect these wireless devices and they will start communicating with each other, and it is called as unguided media. And the best example of this unguided media is your Wi-Fi.
Then we need network interface card or NIC. Okay, so this is the NIC, network interface card, okay, which is connected to your laptop or your desktop. So we need this NIC as well to connect it to the network. Then you will connect the UTP cable to this NIC card. Okay, and this NIC card, also known as network adapter or LAN card, it is a piece of computer hardware used for connecting a computer to network. So you will use this NIC card to connect the computer to the network, either through cables or wirelessly. So we have wireless, so NIC cards for wired network, we have NIC card for wireless network. So these examples, if you see, these examples are of wired NIC card, and we have this wireless NIC card, which will generate the RF signals to connect the devices. And guys, let us try to understand what is this MAC address. Okay, so MAC addresses are unique 48-bit hardware number of computer, which is embedded in the NIC card. Okay, when the manufacturer manufactures the NIC card, they embed one hardware number, which is called as MAC address. If you see, okay, this is our NIC card and it is having one number here. It is called as MAC address. So each NIC card has the MAC address and it is a 48 bits hardware number. So MAC address is also known as physical address of the network device, and we can allow and deny the device based on the MAC address. So what is the use of this MAC address? Okay, why the NIC cards are having this MAC address? So first thing, it is used to recognize the device. It is used to recognize the LAN card. Why we are recognizing the the LAN card? Let us say in your LAN, in your home network, in your wireless router, you don't want others. Okay, let us say you don't want your friend to connect to your network. So what you will do, you will take the MAC address. Okay, first you will join it. Okay, from the access point, what you will do, you will take this MAC address and you will block this MAC address. So when your friend tries to connect, the access point will check the MAC address. It is blocked, so it will not allow him. So based on the MAC address, you can allow the devices. You can deny the devices. And ISP allows the MAC addresses when we pay, and they deny the MAC address when the pack is expired. So ISPs, how they allow you to access the network? So they allow your MAC address in their network, so you will access the internet. When you do not pay to them, what they will do? They will block the MAC address. Okay, so this is the MAC address, and guys, we will see the network devices. So in network devices, we have switch. Okay, let us try to understand what is the use of switch. Switch connects the end devices to share the information and resources in the LAN. So guys, imagine you have some computers. Here in this example, we have PC1, PC2, PC3, PC4, PC5. And we want to connect these 5 computers to a LAN, then we need a switch. You will bring one switch and you will connect all these computers to a LAN. So without switch, we can't imagine the LAN. To connect the devices in a LAN, we need a switch. This is a picture of switch. Okay. And if you see these holes are called as interfaces or ports. Okay. And you will connect your computers using this UTP cable. One end will be connected to this port, the other end will be connected to the PC.
All right, guys. So before moving forward, we'll see the difference between hub and switch. So we'll see what is switch, how switch works. So switch is used to connect the devices on a network so they can communicate with each other. But first time it will do the flooding. From the second time onwards, it will do the unicast. Let us try to understand what does it mean of this sentence. So this is your switch and you have connected 4 computers to this switch. And the IP addresses of these 4 computers are 192.168.1.1, 192.168.1.2, 192.168.1.3, and 192.168.1.4. Okay, so when you connect the devices for the first time, so switches maintain the MAC table. In this MAC table, they have the entries of all the MAC of all the MAC addresses. Okay, of all the computers. Okay, so for the first time, let us say this 192.168.1.1 wants to communicate with 192.168.1.4. The request will go to switch. Switch will check its MAC table, and the MAC table is empty. Switch doesn't know what is the MAC address of 192.168.1.4. In this case, what this switch will do, it will broadcast the message and it will ask who is this 192.168.1.4. It will send the broadcast message to all the devices in the network. Okay, before broadcasting the packet, what this switch will do, it will save the entry of AB, okay, the MAC address of 192.168.1.1 and the port number fast Ethernet 0/1. So before broadcasting, it will save this entry, then it will broadcast it and it will ask who is this 1.4. Other computers, they will ignore this broadcast message because they are not 1.4, and this 192.168.1.4 will send the response back to switch and it will say I am 192.168.1.4 and this is my MAC address 2C. Then this switch will save this MAC address with port number. Fast Ethernet 0/4, MAC address is 2C. What is the meaning of this entry? To reach 2C, switch has to go via fast Ethernet 0/4. And what is the meaning of this first entry? To reach AB, switch has to go via fast Ethernet 0/1 port. Okay, so this is the meaning. If the MAC addresses are not available in the switch MAC table, it will do the flooding, it will do the broadcasting. If the MAC address is available, it will do the unicast. Let us say this 192.168.1.2 wants to communicate with 192.168.1.4. The request will go to switch. Switch is having the entry of 2C. Okay, it is having the entry of 2C and the exit interface is fast Ethernet 0/4. So this time the entry is there. So it will not do the broadcast, it will send the unicast message. And it will save this MAC entry as well, AC and port number is pass Ethernet 0/2. So this is the behavior of switch. You need to remember this. And what is hub? It is used to connect devices on a network so that they can communicate with each other, but it always does the broadcasting. So let us say this is hub here, and we have connected 4 computers. And this 192.168.1.1 wants to communicate 1.4. The request will go to hub. Okay, hub don't maintain any tables. So it will send the broadcast message to all the devices. So it will always send the broadcast message. Whereas switch will send the broadcast message for the first time. From the next time it will do the unicast. Whereas hubs, they send the broadcast message every time any PC wants to communicate with the other computer PC. So this is the difference here.
Then we have one more device which is called as access point or wireless access point. So like switch, it also connect the end devices to share the information and resources, but using RF signals. So this access point also connects the devices in your LAN, but it doesn't use the cables to connect the end devices. It uses the RF signal. Okay, so this is the photo of access point. So you will get the access point in many forms. You will see this access point. Okay, so if you see in this example, we have some wireless devices. Okay, and if you want to connect these wireless devices to a LAN, we need a access point. Using this access point only, these end devices will be connected to your LAN. Okay, and it will give you the Wi-Fi connectivity. So it can cover 10 to 1000 meters area. It is similar to switch, but it uses the RF signal. And we have one more device which is called as WLC, wireless LAN controller. Let us try to understand what is the use of this wireless LAN controller. It provides the centralized management of all the access points in the network. So you might have visited any airport or shopping mall. Okay, so these airports and shopping malls, they cover very large area, and one access point is not enough to cover the complete area of airport or shopping mall. So we install hundreds of access points to cover the complete area. That is why wherever you go, you will get the Wi-Fi connectivity. Okay, because we have installed hundreds of access points. So when we have installed the hundreds of access points, we need to manage them. Let us say we want to upgrade the firmware of all the hundreds of access points. So how will you upgrade the firmware? You will access each and every access point individually and you will upgrade it. If you want to do some configuration, you want to configure some policies on all the hundreds of access points. Again, you will have to access all the hundreds of access points and you will configure the policy. So it is a very tedious task and it is a very time consuming process to access individually. Just give me 1 second. Okay, so we have hundreds of access points, and if you manage them individually, it will take a lot of time and there is an administrative overhead. So instead of managing each and every access point individually, what you will do, you will connect all the access point to WLC. From this WLC, you can manage them centrally. So WLC, it provides the centralized management of all the access points in the network. Makes it easier to manage the multiple access points from a central point. Okay, so we have some pictures of this WLC, and we have a router. Okay, so what is the use of router? It is a networking device which allows different networks to communicate. So let us say we have one LAN in Hyderabad with 3 computers, 1 IP phone and 1 server, and we have one more LAN in Bangalore with 3 computers, 1 IP phone and 1 server. And our requirement is to make these 2 different LANs communicate. So how will you make them communicate? You need a router. You will purchase two routers. One router is for Hyderabad, the other router is for Bangalore. And you will connect the router to your LAN. Let us say this is the Hyderabad router and it will be connected to the Hyderabad LAN. This is the Bangalore router and it will be connected to the Bangalore LAN. Then you will connect this to Hyderabad and Bangalore LAN using MAN link, and you will do some configuration on these two routers, and these two different networks will start communicating with each other. So if you want to make the communication between two different networks, we need a router. Okay, it is a networking device which allows different networks to communicate. So it will make the communication between two different LANs, two WANs, and LAN with internet as well. So let us say you have some computers, and if you want to connect these two computers to a LAN, so we need a switch. And let us say we need to provide the internet access to these computers, then we need a router. Okay, so internet is also a network. Okay, and your LAN is also a network. So to make the communication between these two different networks, we need a router. And called as firewall. So firewall is a network security system that controls network traffic based on security rules you configured on it. So basically, this firewall is used to secure your network. Okay, let us take one example to understand the firewall. So guys, we have some computers and we have, let us say, two servers in our LAN. This server is a web server. The other server is finance server. And this finance server is very confidential server, and web server, through this web server, you promote your products. So your customers visit this website and they purchase the product from this website. Okay, they are all connected to switch. And these devices need internet. Our second requirement is to provide the internet access to these devices. So we will connect the router. We'll connect the router and we provide the internet connectivity to these devices. So as we have discussed, internet is a public WAN. Anyone can connect to it. Let us say the attacker is connected to internet and he wants to attack your finance server. So he is already connected to internet. So from router, he will access your finance server. So to avoid this attack, what you will do? You will configure a firewall between this router and switch. Okay, again, it is an attacker. It is an attacker and he wants to attack this finance server. So from router, he wants to attack the finance server. The request will go to the firewall. Firewall will see that the request is coming from outside. The request is coming from internet and he wants to access the LAN. This is your LAN. Okay, and he wants to access the LAN. So firewall will drop the request. It will not allow the outsider to access the LAN. This is how this firewall secures your network. And guys, firewall is having 3 zones. So guys, firewall is having 3 zones. First is trusted zone. Second is untrusted zone. Third is DMZ. So what is trusted zone or trusted network? Your LAN. Your LAN is your trusted zone because this is your network and you trust it. That is why it is called as trusted zone. And internet is an untrusted zone. Why it is called as untrusted zone? Because it is a public WAN and anyone can connect to it. We don't know who is an attacker and who is a normal user. So internet is called as untrusted zone. And what is the use of this firewall? The Firewall is used to secure your trusted zone from untrusted zone. Okay. And what this firewall will do, it will not allow the users from untrusted zone to access the devices in trusted zone. So here attacker wants to access the finance server. This firewall is not allowing because attacker is in the untrusted zone and he wants to access trusted zone. In the trusted zone, in our LAN, we have one web server. As we have discussed, it is used to promote our website, okay, our products. So let us say a genuine user is connected to internet and he wants to access this website and he wants to purchase something. So again, the request will go to router. From router, the request will go to the firewall. Firewall will see that the request is coming from untrusted zone and he wants to access the server which is in trusted zone. The firewall will drop the request. So guys, is it good not to allow our customers to access the website? No. Okay, it is not good, right? So what we will do, the servers which should be accessed from untrusted zone, we will move them to DMZ. So we will not install the server which should be accessed from outside in our LAN, in our trusted zone. We will move this server from trusted zone to DMZ. This is your DMZ and this is your web server. Now user can access this website. The request will go to router. From router, the request will go to firewall. Firewall will see that the request is coming from untrusted zone and he wants to access a device which is in DMZ. So it will allow it. Okay, so this is the use of DMZ. We install the devices which should be accessed from outside in DMZ. In our trusted zone, we install the devices which should not be accessed from outside. So this is the use of firewall. Okay, so the main scope is to control the traffic coming from untrusted zone. Then guys, we have IP phones. IP phone uses voice over IP for making calls over an IP network. So what is this IP network? The network which we have been discussing, it is the IP network. Okay, yeah, Hyderabad LAN, Bangalore LAN, and they are connecting with each other using this routers. Okay, it is your IP network. So previously guys, we used to have a separate network for calling and separate network for data transfer. For calling, we used to have PSTN, public switched telephone network, and for transferring the data, we used to have IP network. Now we can make the calls over the IP network, okay, using this IP phones. So this is the IP phone here, okay, and you can make the calls. You will connect the IP phone and you will do some configuration, and you can make the calls over the IP network using this IP phone. So these are some pictures of IP phone, okay, and we use the same UTP cable, okay. The UTP cable is used to connect the computers. So the UTP cable we can use to connect the IP phones as well. We don't need a separate cable.
And guys, we have this broadband wireless router. So you might have seen this device in your home to connect to network via Wi-Fi. Okay, so let us try to understand what is the use of this device. Is it a switch? Is it a router, access point, or DHCP server? Let us try to understand. So we'll take one scenario. So let us say guys, you have 4 computers. You have a very smaller network with 4 computers. And you want to connect these 4 computers to a LAN. So which device we need to connect the devices to you? So we need a switch. This is our first requirement to connect the devices to your LAN. So we will purchase a dedicated switch. Now, after connecting your devices to a LAN, our requirement is to provide the internet access to these 4 computers. So guys, which device we need for internet access? Router. We need a router. Then you will contact the service provider. He will provide the internet access. And our third requirement is to allow your wireless devices to connect to your network. Let us say you have some smartphones, laptops, tablets, and you want these wireless devices connected to your network. So to connect the wireless devices, which device we need? Access point. We need an access point. Very good. So this access point allows your wireless devices to connect to your network. Now guys, let us say your fourth requirement is to provide the IP addresses automatically. Guys, you need the IP address to connect to network, to connect to internet. Okay, you need the IP address. And your fourth requirement is to provide the IP address to your end devices automatically. So we need DHCP server. DHCP server, what it will do, it will provide the IP addresses automatically to the end devices. So we can either configure the DHCP on this router, or you need to purchase a dedicated server. Let us say we have purchased a dedicated server and we make this DHCP server, we make this server as DHCP server. So guys, our network is very smaller, let us say from 4 to 15 computers. 4 to 15 computers are there in our network. And for this smaller network, we have purchased switch, we have purchased dedicated router, we have purchased dedicated access point, we have purchased one dedicated server for DHCP. So guys, it is not an ideal solution, it is not a good solution to purchase the dedicated devices for a smaller network from 4 to 15 computers. Instead of purchasing the dedicated devices, what you will do, you will purchase this wireless router. Okay, so instead of purchasing the dedicated devices, you will purchase this wireless router. And this is the picture of this wireless router. So our first requirement was to connect 4 computers to LAN. So if you see, this device is having 4 port switch. So you will connect 4 computers to this switch. And our second requirement was to provide the internet access to this computer. So it is having one port, okay, and it is an internet port. So you will contact the service provider will connect its cable to this adapter. So this device is acting as a switch and it is acting as a router as well. And our third requirement was to provide the connectivity to your wireless devices. So guys, if you see, this device is having some antennas which generates the RF signal to connect your wireless devices. So this device is acting as an access point as well. And our fourth requirement was to provide the IP addresses to the end devices automatically. Okay, so the same device, it will provide the IP addresses to your end devices automatically. Guys, have you ever configured the IP addresses on your mobile phone, smartphone to access the internet? Have you ever configured? Anyone?
No.
Okay. But you need the IP address. Your device required the IP address to access the internet. You haven't configured it. So from where it is getting the IP address? The wireless router. The device which is installed in your home, which provides the IP address automatically to your smartphones. Using that IP address, your smartphone will access the internet. So this device is acting as a switch, router, access point, and DHCP server. It is a 4-in-1 device, guys, and it is suitable for the smaller network.
So we'll see what is operating system. Okay, so to run any device like personal computer, server, mobile phone, we need operating system. Okay, for servers, we need Windows servers operating system, and we can use the Linux operating system. Okay, for mobile phones, we use Android operating system. Okay, so we use this operating system, different operating system, and what is an operating system? Let us try to understand. Okay, we use different operating system for different devices, but what is the use? Let us try to understand what is this operating system. It is a software that acts as a mediator between computer hardware and user. So this is your computer, and let us say this is the user, and this user wants to do something on computer. Let us say he wants to calculate what is 2 plus 2. Okay, so user can't directly communicate with the hardware of the computer because the hardware understands only binary language, which is zeros and ones. Okay, and we don't understand what is zeros and ones, so we need something which translate our language into computer's language. We need operating system here. So it is a software that acts as a mediator between computer hardware and user, and computer hardware understand only binary language, which is zeros and ones, and operating system translates the user instruction into binary numbers and conveys it to hardware. So the request will go to operating system. Operating system will translate your instruction into binary number and it will convey it to the computer. Okay, because computer understands only zeros and ones. This is the mediator, and we have different types of operating systems. Operating systems are divided into two categories. One is client operating system, the other one is server operating system. Let us try to understand the difference between these two operating systems. Client operating system, it is installed on client machines like desktop and laptop. So you will install this client operating system on laptop and desktop, or you can say you will install it on your PCs, personal computers. And what is the use of this client operating system? It is used to obtain the services from server. This client operating system will obtain the services from the server operating system. And we have some examples of client operating system like Windows XP, Windows Vista, Windows 7, Windows 8, and Windows 10. And nowadays we have Windows 11 as well. Okay, so these are the examples of client operating system. And we have server operating system. It is designed to be used on servers. So guys, we have these different hardware servers, tower server, blade server, rack server. So all these servers required operating system. So this server operating system is designed to be installed on these hardware servers. It is designed to be used on servers. It is used to provide the services to multiple clients. So what this server operating system does, it provides the services to client operating system. Okay, and it can serve multiple clients at a time, and it is very advanced operating system. Let us say you have installed a web server. We have installed the server operating system and you have installed this server as web server. Okay, so multiple clients can access this website. Okay, so it is designed, it can serve the multiple clients at a time, and it is very advanced operating system. This is the difference between client operating system and server operating system. We have some server operating system examples like Windows NT 3.1, Windows NT 3.5, Windows NT 4.0, Windows NT 5.0, and later it was renamed as Windows Server 2000. Then we have Windows .NET Server. Again, later it was renamed as Windows Server 2003. Then we have Windows Server 2008, Windows Server 2012, Windows Server 2016, Windows Server 2019, and Windows Server 2022. This is the latest version. And NT stands for new technology, and till Windows NT 4.0, till here, operating systems were developed in C language. After that, from Windows Server 2000, okay, from here, the operating systems are developed using .NET technology.
Windows Server 2022 has 3 editions. First is Essential Edition, Standard Edition, and Data Center Edition. What is Essential Edition? The license is limited to 25 user accounts, which means if you are using Essential Editions, you can create only 25 users. If you are using Standard Edition, you will get the full Windows Server functionality and you can create only 2 virtual machines. If you are using Data Center Edition, again you will get the full Windows Server functionalities. You can create unlimited users with unlimited virtual machines. Let us see the hardware requirement to install the Windows Server 2022 operating system. The processor, you should have minimum one processor with 1.4 gigahertz and it should be a 64-bit processor. And maximum it supports 64 processors. And if you are configuring if you want to do the virtualization, the processor should support virtualization technology. If you are purchasing Intel, it should be Intel VT. If you are purchasing AMD, it should be AMD V. And memory, if you talk about RAM, minimum you should have 512 MB RAM, which is not recommended. At least you should have 4 GB RAM. 4 GB RAM is recommended to install the operating system, and it supports maximum 4 TB RAM. And hard disk space, you should have at least 10 GB RAM. Again, it is not recommended. You should at least have 80 GB or greater space. You will see how to install the Windows Server operating system. There are multiple ways to install the operating system. So installation can be done by DVD. You will take the Windows Server DVD, you will insert the DVD into the DVD drive of the server, then you will power on the server. Server will detect this DVD and it will install the operating system. We can use the USB flash as well. You will save the operating system files on this USB flash drive. You will make it bootable. You will connect this USB drive to the server and you will power on the server. It will detect this USB drive and it will start installing the operating system. We will see how to install the Windows Server operating system. There are multiple ways to install the operating system. So installation can be done by DVD. You will take the Windows Server DVD, you will insert the DVD into the DVD drive of the server, then you will power on the server. Server will detect this DVD and it will install the operating system. We can use the USB flash as well. You will save the operating system files on this USB flash drive. You will make it bootable. You will connect this USB drive to the server and you will power on the server. It will detect this USB drive and it will start installing the operating system. Or we can use the ISO file to install the operating system. We will download this ISO file from Microsoft site and we will install it. And in our lab, we are going to use the ISO file. So in this section, we will discuss about computer specifications for our lab. So you can have desktop or laptop, and the processor speed of your computer should be minimum 1.4 gigahertz. 2 gigahertz speed is recommended, and it should support virtualization. RAM, so your computer should have minimum 6 GB RAM. 8 GB RAM is recommended. Hard disk, so your computer should have 30 GB free space in your hard disk. 50 GB free space is recommended. Operating system, you can use Windows 8 or Windows 10. Windows 10 is recommended. We'll verify the specification of my computer. So we'll go to this PC, right click, then we'll go to more, then we'll go to properties. And here if you see, the processor speed of my computer is 2.4 gigahertz, and the RAM size is 32 GB, and Windows operating system is Windows 10. Verify the hard disk free space, we need to go to this PC, double click on this PC, and if you see here, 356 GB free space is available. After that, we'll verify whether my CPU supports virtualization or not. So we'll go to task manager. Under this task manager, we'll go to performance. Under performance, we will see virtualization is enabled here, which means it supports virtualization, and virtualization is enabled. In this section, we'll see software required for Windows Server 2022 labs. First, we need Windows Server 2022 ISO image, which can be downloaded from Microsoft website. This is the link to download the ISO image. And we need VMware workstation software as well. So why do we need this VMware workstation software? To create the virtual server. So guys, we are going to use the virtual servers to install the Windows Server 2022 operating system. These virtual servers are equivalent to the physical server. The functionality of this virtual server is equivalent to the physical servers, and we'll provide these links in our next section. In this section, we'll see how to download the Windows Server ISO image. We'll copy the link and we'll paste this link to this browser. And if you see here, we have got this option, Windows Server 2022 evaluation 180 days. So it is a trial version. You can use this ISO image for 180 days. Then we need to select this download the ISO option. Then we'll click continue. Then we need to provide the information like first name, last name, company size, job title, work email address, work phone number, country or region. Let us provide this information. Job title, system administrator. Then we'll click continue. Then we need to select the language, English. Then we'll click this download option. If you see here, the downloading is started, and the size of this ISO image file is 5.2 GB. It will take a lot of time to download this file. So I have already downloaded this file. We'll cancel this download. Let me show you how the ISO image looks like. So it is already downloaded on my desktop. There is a folder called software. We'll click it. Under this software, we have ISO images. Under ISO images, we have a folder called Windows Server 2022. This is the ISO image of Windows Server 2022. In this section, we'll see how to download VMware Workstation and install it. First, we'll copy this link. Then we'll paste this link here. And it has started the downloading. If you see, 11 minutes are remaining. So we'll wait for the download to be done. So guys, the VMware workstation is downloaded. We'll install it now. We'll double click on it. It is preparing for the installation. We'll click next. We'll accept the terms in the license agreement. Then we'll click next. We'll click next, 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 install. So it will install the trial version, which is enough for you to practice the labs. So VMware workstation is installed. We'll click finish, and you can see the icon on the desktop. You'll double click on it. So I want to try VMware workstation 16 for 30 day. Continue, finish. This is the interface of VMware workstation. From here, you can create the virtual machine, or you can say you will create the virtual server. Guys, this is the interface of VMware workstation. And here only we will create the virtual servers. After creating the virtual servers, we will see how to install the operating system. So let us create a virtual server or virtual machine. We'll select this first option, and we'll go with the recommended settings, which is typical. Then we'll click next, and you will get three options here: installer disk image file, and I will install the operating system later. So you will select the third option, I will install the operating system later. Means we will create the virtual machine first, then we'll install the operating system. This is the meaning of this third option. Then we'll click next, and we are going to install the Windows operating system. Okay, so Microsoft Windows. And what is the version we are going to install? We are going to install Windows Server 2022. Okay, and this VMware workstation, they have not updated their software. Okay, they have this option till Windows Server 2019. So we will select the latest version available on this workstation, but we will install Windows Server 2022 only. Okay, so you will select this option here, then we'll click next, and we'll provide the path to this virtual machine. Where do we want to save this virtual machine? On your computer, on your local computer. So we'll go to C, we'll create one folder, new folder, and MCSC 7 p.m. batch. So we will save the virtual machines on this folder. Okay, under this folder, we will create one more folder, and we'll provide the name to this folder as server-01. Okay, under this server-01, we are going to save the files of this virtual machine. Okay, and the name should be appeared here. Okay, it is showing new folder. Now it is showing server 1. Then we'll click OK. Then we'll click next. So we can provide the name to this virtual machine as well. So let us provide any meaningful name. Again, we'll provide the name as server-01. Then we'll click next, and the hard disk, it is selected 60 GB by default. Let us give 100 GB. 100 GB, and we will select the default setting. We'll go with the default setting, split virtual disk into multiple files. Then we'll click next, and here you will give you the information about what you have selected, like name server-01, and where you are going to save this virtual machine, virtual server. This is the path. Okay, and what is the version of this workstation, 16.x, and which operating system we are going to install. It is showing 2019, but we are going to install 2022 because it doesn't have the option 2022 here. We have selected the latest one, and hard disk space is 100 GB and memory is 2 GB. Okay, so you will get this information, and you will click OK, finish. You will click finish, and your virtual machine is created. You will get the virtual machine here, server-1. Now guys, and your virtual machine is created. You will get the virtual machine here, server-1. Now guys, we have the virtual machine. Let us say in real environment, we have the physical server, and we need to install the virtual machine. We need to install the operating system on this machine. So you will go to edit virtual machine setting option. Then you will select this CD DVD option, and we are using the ISO image. So you will select the second option, use ISO image file. Then we will browse. We have saved the ISO image on the desktop. We'll go to software folder. Under this software folder, we'll go to ISO images. Under this ISO images, we have Windows Server 2022. Okay, so we'll select that ISO image of Windows Server 2022. Then we'll click OK. So we have given the path of that ISO image. Now we will power on the virtual machine. How will you power on the virtual machine? You will select this option, power on this virtual machine. Okay, guys. So we'll select this Windows setup option. We need to select the language. So we'll go with English United States. We'll click next. Then we'll click this install now option. Okay, so you will get some options here, like which version you want to install. Windows Server 2022 standard evaluation. Okay, this option is for the CLI based operating system. Then you have Windows Server 2022 standard evaluation and desktop experience. Desktop experience means it will install the GUI operating system. Then we have Windows Server 2022 data center evaluation. This option again, it will install the data center evaluation, but it will be CLI, not the GUI. And the fourth option is Windows Server 2022 data center evaluation desktop experience. So it will install data center operating system. Okay, we have seen it is having different editions. So data center edition and desktop experience means it will install the GUI. So we'll go with GUI, will install the data center GUI. Okay, we'll click next. So we need to accept the license agreement. Then we'll click next. And guys, the first option is to upgrade the operating system. Upgrade means you already have installed the operating system and you are upgrading it. And the second option is install the Microsoft servers, which means we are installing the server from the scratch. So we'll go with the second option because we need to install the operating system from scratch. Then where do you want to install the operating system? So you will click disk drive 0. We have only one drive, so it has automatically selected this drive 0. Then we'll click this option new and we'll click apply. So what this option will do, it will create some partition, okay, supporting partition 1, partition 2. In these two partitions, it will save the supporting files. In the partition 3, it will install the operating system, and the size of this partition 3 is 99.9 GB, and this will be your C drive. Okay, so let us click next, and it will start installing the operating system. So it will follow these steps. It will copy the Microsoft Server operating system files. Then it will it will be getting the files ready for installation. After that, it will install the features. After that, it will install the updates. Then it will finish up the So guys, the installation is done. It is restarting the server. Okay. So this operating system will create one username administrator by default, and here we need to provide the password. So let us provide the password, and the password will be like capital M CSE123 $. This is the password. We need to confirm the password MCSE123 $. Same password. Then we need to click finish. Okay, then we need to log in to this computer. We need to press Control Alt Del to unlock. So how will you press the Control Alt Del on this virtual machine? You will click this option, send Control Alt Del to this virtual machine. Then we need to provide the password here. Okay, the password is capital MCSE123 $. Okay, then we'll click enter. Now this operating system is creating the profile for you. Profile is nothing but it is creating the space for you to work on this server. So guys, this is the desktop here, and on this desktop, if you see, it is having only one icon, recycle bin. So let us set up the other icons. So how to set up the icons? You will go to start, right click, then you will select this settings option. Under this settings option, you will select personalization. Personalization, then you will select this themes option. Under this themes, you will select desktop icon settings, and you will check computer, users, file, network. Recycle bin is already checked and it is available on the desktop, and you will check this control panel option. So you will get the other icons also on the desktop. We'll close, and if you see, it is having all the icons now on the desktop. And guys, if you observe one thing here, the screen is not full. Okay, it is having some stripes. Okay, why? Because we have not installed the drivers yet. We need to install the drivers also, and you will get the drivers from here. You will go to VM, then install VMware tools. So these drivers you will get from the VMware workstation. Then you will go to this PC. Then you will select this option. Now we'll click next, install. As if you see here, it is installing the drivers. Now we are getting the full screen. Okay, it is installed and it required restart. We'll click finish, and after installing the tools, it will restart the server. Okay, let us log on to this server. The server is restarted. Okay, all right, guys. So let us see what is the server name. By default, the operating system will provide a server name. Okay, let us see what is it. We'll go to this PC. Then we'll go to properties. This PC properties. Then if you see here, the device name is like Win V6 HIMM QQ 869. It is provided by the operating system. So we should provide any meaningful name. So how to rename this server name? You will select this option. Rename this PC. Then let us provide server 1. The name of the server is server 1. Then we'll click next. Again, if you change the server name, we need to restart the server. Alright guys, the server is restarted. Let us verify the name. We'll log on to this server. Then we'll go to this PC. Okay, we'll wait for a few seconds. We should wait for few seconds after restarting the server. We should let the server settle down. Let us verify the name. We'll go to this PC, then properties. And if you see, the name is changed to server 1. So we have already created the virtual machine and we have installed the Windows Server operating system and we have set the icons and we have installed the VM tools as well. And we have changed the server name and let us create the user account for any administrator. You have, let us say, one administrator and you need to create the username for him. So you will use this command. You will go to command prompt and you will run this command lusrmgr local user manager .msc. So you will find two options, users and groups. So you will go to users. Under this users, we have administrator here and we want to create one more user here. So you will right click here, new user, and let us give username as Asif. Then Khan. And if you want, you can provide the description and you need to confirm the password here. So we will provide the same password, MCSE123 hash dollar. MCSE123 hash dollar. For easiness, we are providing the same username and password, but in real network, you should provide the different passwords. And user must change the password in next logon. So we don't want the user to change the password at next logon. So we'll uncheck this option. Okay, and user cannot change the password. We will discuss about these options in our coming classes. So we'll select this create option and we'll close it. This username is created. Let us log on to the server using this new username. Okay, we'll sign out from this user. Then Control Alt Del. Then you can see the users are available here. So we'll select this Khan. Then MCSE123 hash dollar. So guys, we are login to this server for the first time with this new user. So again, it will create the profile for this new user. Profile is nothing but it will create the space for this user to work on this server. So if you see here again, it is having only recycle bin on the desktop. We need to set the icon up. Okay, we'll go to settings. We'll go to personalization. Then we'll go to themes. Under themes, we have desktop icon settings. Then we'll check all the icons. Then we'll click OK. You can see all the icons here, and this is a folder for this user Khan. Okay, which means we have logged in with Khan. You can see on the desktop itself.
In this section, we will discuss about IP address. As we have discussed, to form a network, we need the IP address. So what is IP address? It is a logical address assigned to all the devices in the network. So in this example, if you see, we have 4 computers, and all these 4 computers are having some numbers. These numbers are IP addresses. Okay, so it is a logical address. Logical address means we can change this IP address. And what is the use of this IP addresses? It is used to identify the specific device in the network. If you want to identify any device in the network, you will assign the IP address, and this IP address is used to make the communication between the devices here. It is like the mobile number. Mobile phones should have the mobile number for communication. The same way, computers should have the IP address for communication, and it has 2 versions, IP version 4 and IP version 6. IPv4 or Internet Protocol version 4 is a 32-bit IP addressing. 32-bit IP addressing means we will get 2 power 32 IP addresses with IP version 4, which is equal to 4.3 billion IP addresses. So this IP version 4, it was deployed in 1980s, and at that time 4.3 billion IP addresses were more than enough. But the network was growing very fast, and it was realized that there will be a shortage of IP addresses one day, and scientists have started working on the solution, and the solution is IP version 6. In IP version 4, the IP address has 4 portions. Each portion is separated by dot. So in this example, we have one IP address 192.160.7.1. If you see here, it is having 4 portions, 1, 2, 3, 4, and each portion is separated by dot here. If you take some more example, we have 192.168.1.1. Okay, this IP address is assigned to this computer, and it is having 4 portions, 1, 2, 3, 4, and each portion is separated by dot here. And it has 32 bits. So each IP address has 32 bits. So if you configure the IP address to any computer, the computer will convert the IP address into binary numbers. Binary numbers means zeros and ones. Okay, so this is the decimal number. Decimal number means 0 to 9. And we configure the IP address in decimal format, and computers convert the decimal IP address into binary numbers. So 192 will be converted to binary numbers, and it will be like 2 ones and 6 zeros. If you see, it is having 8 bits here. 160 will be converted to binary numbers, and the binary number of 160 will be 101 and 5 zeros, and it is having 8 bits. And 7 will be converted into binary numbers, and the binary number of 7 will be 5 zeros and 3 ones, and it is also having 8 bits. Then 1 will be converted into binary numbers, and it is having 7 zeros and 1. Again, the 4th portion is having 8 bits here. So if you add 8 plus 8, 16, 16 plus 8, 24, 24 plus 8, 32. So you will get 32 bits here in each IP address. IP version 6 or Internet Protocol version 6 is a 128-bit IP addressing, which means we will get 2 power 128 IP address, which is equal to 340 undecillion IP addresses, which means if the device is getting double every year for 50 years, there will be no shortage of IP address with IP version 6. But still we are surviving with IP version 4. Still we are using IP version 4 because we have some temporary solutions like subnetting and netting. Because of these 2 temporary solutions, we are still surviving with IP version 4. So as we have discussed, IP version 4 is a 32-bit IP addressing, which means each IP address will have 32 bits. So if in this example, if you see here, we have one IP address, and this IP address is 192.160.7.1. This is the IP address, 192.160.7.1. Okay, so 192.160.7.1 is the IP address. So when you configure this number, it is called as a decimal number. Decimal number is from 0 to 9, and this IP address in the decimal format. So when you configure any IP address to the computer will convert this decimal IP address into binary number, because computers understand only binary numbers. They understand zeros and ones. They don't understand the decimal number. And after converting your IP address, this IP address looks like this: 2 ones, 6 zeros, 1 0 1, 5 zeros, 5 zeros, 1 1 1, 7 zeros and 1. Okay, this is 192.160.7.1. So IP version 4 is having 4 portions or 4 octets, and each octet or portion is separated by dot. Okay, so it is having 4 portions. Each portion is separated by dot. You can see 1, 2, 3, 4. 4 portions are there, and each portion is separated by dot. And let us see. So this is the binary number. This is 192, and let us see how to convert this binary number into decimal number. And each octet, if you observe here, having 8 bits. 2 1 6 zeros, 8 bits. 1 0 1 5 zeros, 8 bits. 5 zeros, 3 ones, 8 bits. 7 zeros and 1, it is also having 8 bits. If you add up all these bits, you will get 32 bits. Okay, so that is why it is a 32-bit IP addressing. And let us see how to convert this binary number into decimal number. So first, what you will do, you will take the first portion, which is 1 6 zeros. If you see here 1 1 1 2 3 4 5 6 zeros, then you will write the 2 power series. 2 power series, it will be like this: 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, then 2 power 7. This is your 2 power series. Then you will calculate these values. What is the value of 2 power 0? It is 1. Anything power 0, the value will be 1. Then what is the value of 2 power 1? It is 2. 2 power 1 is 2 into 1. You will get 2. And what is the value of 2 power 2? It is 2 into 2, which is 4. Then what is the value of 2 power 3? 2 into 2 into 2. 2 2s are 4, 4 2s are 8. So the same way you will calculate all the values. 2 power 4, it will be 16. 2 power 5, it will be 32. 2 power 6, it will be 64. 2 power 7, it will be 128. After that, we will consider only ones. These ones. Okay, we will consider the values which is above this binary one. 128 plus 64, 192, and you will ignore all the zeros here. So the value of 1160 is 192. Let us convert the other values. We will take the second octet 101, then 5 zeros, 1 2 3 4 5, 5 zeros. Then you will write the 2 power series: 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Then you will calculate the values. What is the value of 2 power 0? It will be 1. 2 power 1, it is 2. 2 power 2, which means 2 into 2, it will be 4. 8, 16, 32, 64, 128. Then again you will consider the binary ones. You will take the values which are above this binary ones. 128 plus 32. You will ignore the zeros. So 128 plus 32, it is 160. 192.160. Let us calculate the third octet. Let us convert the third octet to decimal. Let us convert this third binary octet to the decimal. And again, you will take the binary numbers like 5 zeros, 1, 2, 3, 4, 5, then 3 ones, 1, 2, 3. After that, you will write the 2 power series like 2 power 0, 2 power 1 till 2 power 7, or directly you can write this value 1, 2, 4, 8, 16, 32, 64 and 128. Then you will consider only the values which are above binary ones. 4, 2 and 1. 4 plus 2, 6. 6 plus 1, 7. You will get 7 and you will ignore the zeros. Let us take the last octet. Let us convert the last octet into decimal. So last octet is 7 zeros and 1. Again, we will consider only the numbers which are above the binary one. So above the binary one, we have only 1. So we will write 1 and we will ignore the zeros. And the IP address is 192.160.7.1. This is how you will convert the binary to decimal. Okay, we have converted the binary numbers to decimal. In this section, we will convert decimal numbers into binary numbers. Decimal numbers are from 0 to 9 and binary numbers are zeros and ones. So we'll take one IP address 200.17.100.3 and we'll convert this IP address into binary numbers. So first we'll write this IP address into column like 200.17.100.3. Then we'll write 2 power series, 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, then 2 power 7. Then we'll calculate this number. The value of 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8 and so on, and the value of 2 power 7 will be 128. So we should convert 200 into binary numbers first, then 17 into binary numbers, then 100 into binary numbers, then 3 into binary numbers. To make the calculation simple, we will convert 3 into binary numbers first. We'll see where we are getting this 3. Okay, we will add 2 plus 1, which is equal to 3. So we are getting 3 here, 2 plus 1. At the place of 2, you will write binary 1. At the place of 1, you will write binary 1. And on other places, you will write zeros. And the binary number of 3 will be 6 zeros and 2 ones. Then we'll convert 17 into binary numbers. 16 plus 1, you will get 17. So at the place of 16, you will write 1. At the place of 1, you will write 1. On other places, you will write zeros. And the value of 17 is 0001, 0001. Then we will convert 100 into binary numbers. Let us see where will we get 100. 64 plus 32, it is 96. 96 plus 4, you will get 100. So at the place of 64, you will write 1. At the place of 32, you will write 1. At the place of 4, you will write 1. On other places, you will write zeros. And the binary number of 100 is 011 00100. Let us see how to convert 200 into binary numbers. 128 plus 64 plus 8, it is 200. So at the place of 128, you will write 1. At the place of 64, you will write 1. At the place of 8, you will write 1. On other places, you will write zeros. The binary numbers of 200 will be 11 001 000. In this section, we will see how to assign the IP address to Windows Server. We will go to Control Panel first. Under Control Panel, we'll go to network and internet option. Under network and internet option, we'll select view network status and task. Then we'll select change adapter settings. Then we'll go to the adapter where you want to configure the IP address, right click properties. Then we will get this window. Under this window, we have two options, obtain an IP address automatically, use the following IP address. So we'll select the second option and we'll configure the IP address like 10.0.0.1 and the subnet mask is 255.0.0.0 and it is having some other options like default gateway, preferred DNS, alternate DNS. We are going to discuss all these options in our coming classes.
Let us go to the server and assign the IP address. We'll go to the server one. Then we'll go to control panel. Under control panel, we'll go to network and internet. Under network and internet, we'll select view network status and tasks. Then we'll go to change adapter settings. Under change adapter settings, we'll select the adapter where we want to configure the IP address. Then we'll right click. We'll go to properties. We will double click on internet protocol version 4. Then we'll select this, use the following IP address option. And guys, we are going to use 10 network. We'll configure the IP address 10.0.0.1 to this server 01 and the subnet mask will be 255.0.0.0. It is having some other fields like default gateway, preferred DNS and alternate DNS. We are going to discuss all these different fields in our coming classes.
Okay guys, let us see. As we have discussed, IP version 4 is having 4 octets or 4 portions like 192.168.1.1. So it is having 4 portions or 4 octet, 1, 2, 3, 4 portions are there and each portion is separated by dot. So guys, let us see what is the minimum number you can configure or enter in each octet and what is the maximum number you can enter in each octet. Okay, so the minimum number is 0, the maximum number is 255. We can't go beyond 255. If you try to configure 256, you will get the error. We can't go beyond 255. Let me show you. So if you go to this adapter and we try to configure 256. So it is saying that 256 is not a valid entry. Please specify a value between 0 and 255. You can see the minimum value is 0, the maximum value is 255. You can't go beyond 255. And guys, as we have just discussed, the range is from 0 to 255. Again, this range is divided in 5 classes. From 0 to 127, it is called as class A. From 128 to 191, it is called as class B. From 192 to 223, it is called as class C. And from 224 to 239, it is called class D. 240 to 255, it is called as class E. You can see from 0 to 255, this range 0 to 255 is divided in 5 classes. Let us try to understand what is this classes. Okay, so class A, B and C we can use in LAN and WAN, which means we can configure the IP addresses from these 3 classes. But class D and class C, they are reserved for some special purposes and we can't use these ranges in our network. 224 to 239, it is reserved for multicasting, and 240 to 255, it is reserved for research and development. And these 2 classes we can't use in our LANs and WANs. If you try to configure the IP address from this ranges, computer will not accept it. Let us try to configure the IP address from class D and class C. So class D is starting with 224. Let us configure the IP address from 224. So as soon as I entered 224, the computer is giving this error. 224 is not a valid entry. Please specify a value between 1 and 223. Till here. So after that, we can't use any network. If you try to configure the IP address from class C, let us try to configure 240. You will get the same error. 240 is not a valid entry. Please specify a value between 1 and 223. Okay, so guys, we have three types of network communication. One is called as unicast, broadcast, and multicast. What is the meaning of unicast? Let us try to understand. So in this example, we have 4 devices connected to this switch, and this computer has generated, this is the printer here, 3 computers are there, 1 printer is there. So this computer has generated the print command to this printer. So the request will go to this printer from this computer, and it is one-to-one communication from PC to printer. It is called as unicast. If you see here, we have multiple devices, but it is communicating with only one computer, which means unicast. So it is like when you call your friend and you are talking to your friend one-to-one, and the communication is called as unicast. Let us try to understand what is broadcast. Okay, broadcast means, again we will take this example here. We have 3 computers and 1 printer, and this computer wants to send the same packet to all the devices in your network. Let us say you have 200 computers in your network, and this computer wants to send the same packet to all the 200 computers in your network. So it will send it, it will broadcast it, the same packet to all the devices. Okay, it is one to all, sending the packet from one device to all the devices in the network. It is called as one to all. If you see here, this one computer is sending the packet to all the devices in your network. It is called as broadcasting one to all. Then guys, we have multicast. In multicast, it will send the packet to group of computers. It is not one to all, not one to one. It is one to many. It is sending the one packet to few computers in your network. In this example, this computer wants to send the packet. Let us say you have 200 computers, but it is sending the packet to these 2 computers only. Okay, it is one to many. If you see here, we have multiple devices here, but this computer is sending the packet to selected devices. And guys, the best example of this one to many is Netflix. The example of this multicast is Netflix. The service is not available for everyone. You need to pay to them. So when you pay to them, they will give you the service. Okay, the service will be for the selected people. So unicast, the process of sending a packet from one host to an individual host, one to one. Broadcast, the process of sending a packet from one host to all the hosts in the network. Multicast, the process of sending a packet from one host to a selected group of hosts. And this class G is reserved for multicasting. As we have discussed, IP version 4 is having 4 portions. And these 4 portions are again divided into network and host portion. Class A is having 1 network portion and 3 host portion. Class B is having 2 network portions and 2 host portions. Class C is having 3 network portions and 1 host portion. So guys, we will see why it is divided into network and host portions. So before that, we need to understand what is the meaning of network and what is the meaning of host here. So in this example, we have 4 computers connected to this switch. These 4 computers are hosts. Okay, and this set of devices, set of these computers, it is called as network. Okay, host is a specific device in the network and network set of devices. Let us try to understand why we have network portion and host portions. So why IP address is divided into network and host portion? So guys, let us say you have 4 computers. You have 4 computers, and to make the communication between these 4 computers, we need 2 conditions to be fulfilled. The first condition is physical connectivity should be there. The second condition is logical connectivity should be there. Physical connectivity means you should connect the devices using cable. This is the physical connectivity. And logical connectivity means you should configure the IP addresses from the same network. Okay, let us try to understand what is the meaning of this configuring the IP address from the same network. Okay, first condition is physical connectivity is already there. Second condition, logical connectivity. Logical connectivity means IP addresses should be configured from the same network, then only they will communicate. We will see what is this same network. We will try to understand what is this same network from this flat numbers example. So guys, let us say I am saying I am living in a flat number 431. So what will you figure out from this number? The first portion is it represents the floor number. So you will come to the 4th floor and you will search for the flat number 10. If I say I am living in a flat number 411, again, what will you figure out from this number? From the first number, you will come to the 4th floor. It indicates the floor. And the other numbers, they indicate the room number. So these 2 flats, 410 and 411, they are on the same floor because this first number is same. Here 410 and 511, guys, these 2 numbers, these 2 flats are on the same floor or different floors? Different. How's the floor?
4th and 5th.
4th and 5th. They are on different numbers. How did you identify?
It's the floor.
You have seen the first number, correct?
Yes.
Okay, this first number should be same to be on the same floor. So the same way, if you want, okay, the same way, the IP addresses, network portion should be there, same, to be in the same logical network. Let us try to understand with this example. We have 2 IP addresses here. Let us say you have 2 computers and we want to make the communication between these 2 computers. So as we have discussed, it should fulfill 2 conditions. Physical connectivity should be there and the logical connectivity should be there. Logical connectivity means the computers belong to the same network. How will you identify whether these 2 computers belong to same network or not, same floor or not? So if you see this example here, 192.168.1.1, let us say we have assigned this IP address to first computer, 192.168.1.1. 168.1.1, and we have assigned the IP address 192.168.1.2. IP addresses are assigned, but we don't know whether they belong to same network or not. So guys, in class C, we have 3 network portions and 1 host portion. So these 3 network portions, the first 3 portions should be same, to be in the same network, to be in the same logical network. So 192, 192, 168, 168, 1 and 1. First 3 portions are same, which means these 2 IP addresses are in the same network. The logical connectivity is there and they can communicate with each other. If you see this example here, 192, some second example, 192.168.1.1, 192.168.9.2. Okay, so this 192 belongs to class C. In class C, we have 3 network portions and 1 host portion. So 3 network portions should be same, to be in the same network. So here 192, 192 it is same, 168, 168 same, but the third portion is not same, 1 and 9, which means they don't belong to same network, they don't belong to same same floor, and they will not communicate with each other. They belong to different floors, they belong to different networks. It is not forming the logical connectivity here. Let us take the example of class B. So in class B, we have 2 IP addresses, 172.16.12.10, 172.16.15.15. So how will you identify whether these 2 IP addresses belong to same network or different network? What is the class here? 172.16, it belongs to class B. In class B, we have 2 network portions and 2 host portions. So the first 2 portions should be same, to be in the same logical network. So 172, 172 same, 16, 16 it is same, and the host portion, it should be different. So these 2 IP addresses belong to same network, which means the logical connectivity is there and they can communicate with each other. But here if you see 172, 172 first portion is same, 16 and 22. Second portion is not same, which means they don't belong to the same network, they don't belong to same floor. They are from different floors and they can't communicate with each other. If you take one more example, 10.25.15.12, 10.12.15.15. So this 10 belong to class A. In class A, we have 1 network portion and 3 host portion, which means the first portion should be same for the communication, for making the logical connectivity. So here 10 and 10, it is same, and the other 3 portions should be different. And here the first portion is same, it is forming the logical connectivity and they can communicate with each other. But here in the second example, the first portion is different, even though they belong to class A, but the first portion is not same, so they don't belong to the same network, they can't communicate with each other. You need to remember this point. Okay, so physical connection devices are connected using media like UDP example. Logical connected means IP addresses should be configured in the same network. Same network in the sense the network portion should be same of both the IP address or all the IP. Now guys, let us say you have connected 200 computers to your network. So computers are connected to the network. Physical connectivity is there, but we need to provide the logical connectivity as well. We need to assign the IP addresses from the same network. So how will you decide, okay, which class you are going to decide and how will you select the IP addresses? So if you go with class C, in class C we have 3 network portions and 1 host portion. So in host portion, okay, each portion is having 8 bits, correct? We have seen network portion is having these 3 portions, okay, having 8 bits, and this host portion is also having 8 bits. Okay, so if you calculate the IP address, it will be 2 to the power of h, okay, 2 to the power of host portion, which is equal to 2 to the power of 8, and you will get 256 IP addresses in class C. Okay, our requirement is of 200 IP addresses, and if you go with class C, we are getting 256 IP addresses, which means class C is fulfilling our requirement. So we'll take any network from class C. Let us take 192.168.1.0 IP address, and then you will start writing the IP addresses. You will increment the fourth octet. The series will be like this: 1.0, 192.168.1.0, 192.168.1.1, 1.2 till 1.255. So total you will get 256 IP addresses including 0. Total 256 IP addresses are there. So guys, first three portions must be same to be in the same network. So if you see, the first three portions are same, the last portion we are changing it. And number of total hosts in each network are 256. So if you are going in class C, you will get 256 IP addresses in each network. So you are going to provide the IP addresses from this network. The first PC, let us say, it will get 192.168.1.1, 1.2 second PC, third PC 1.3, fourth PC 1.4. Like this, you will provide the IP address. You are not going to change the network portion here. You are not going to assign the IP address this way. One IP address you are providing 192.168.1.1, and the other PC you are providing the IP address 192.168.2.2. It is not going to work. Okay, because network portion should be same, and we are giving the different network portion here, and they will not communicate with each other. The network portion should be same. You should remember this point. Now guys, let us say your requirement is 10,000 hosts, 10,000 IP addresses. You have connected 10,000 computers to your network. Physical connectivity is there, and we need to provide the logical connectivity. Logical connectivity means the IP addresses should be from the same network. So we can't go with class C, because in class C we have only one host portion, and in that one host portion you will have only 8 bits. 2 power 8 means you will get 256 IP addresses only in each network. So we can't go with class C. Let us go with class B. In class B, we have 2 network portions and 2 host portions. Okay, 2 host portion. How to calculate how many hosts you will get? 2 to the power of h. H means host portion. So 8 plus 8, 16. 2 power 16 IP addresses you will get. 2 power 16 means you will get 65,536 IP addresses in class B network. Our requirement is 10,000 hosts, and we are getting 65,000 IP addresses here, more than 65,000 IP addresses. So it is fulfilling our requirement. Then we will select any network from class B, and the class B network is 172.16.0.0 we have selected, and you will increment the fourth octet first. The series will be like this: 0.0, 0.1, 0.2 till 0.255. Guys, we can't go beyond 255. So as we have already seen, minimum 0, maximum 255. We can't go beyond 255. So we will move to the third octet and we will increment. It was 0.0, now it will be 1.0, 1.1, 1.2 till 1.255. Again, we can't go beyond 255. We will increment the third octet, and the series will be like this: 2.0, 2.1, 2.2 till 2.255. Then you will move to the third octet. Again, the series will be like 3.02 till 3.255. Then 4.0 till 4.255. So till when you are going to write the IP addresses, till it reaches, the host portion reaches 255.255, and you will get 65,000, 5,036 IP addresses. And guys, let us say your requirement is 70,000 hosts. You have already connected the devices to the network, and we need the logical connectivity. We need to provide the IP address from the same network. So we can't go with class C because you will get 256 IP addresses. We can't go with class B because you will get more than 65,000 IP addresses. So we need to select the class A. In class A, we have one network portion and 3 host portions. 3 host portion means 8 plus 8, 16. 16 plus 8, 24. 24 host bits are there. 2 power 24, you will get 16, more than 16 million IP addresses. Okay. So our requirement is 70,000 and we are getting more than 16 million IP addresses here. And we will select any network from class A. So we have selected 10.0.0.0, and again you will increment the last octet. The series will be like this: 0.0, 0.1 till 0.255. We can't go beyond 255. We will increment the third octet, and the series will be 1.0, 1.1, 1.2, 1.3 till 1.255. Again, we can't go beyond 255. The series will be from 2.0, 2.1, 2.2 till 2.255. So till when you are going to write, till these 2 octets, these 2 portions reaches 255.255. We can't go beyond 255, then we will move to the second octet. The series will be like this: 10.1.0.0, again 10.1.0.1, 0.2, 0.3 till 0.255. Then 10.1.1.0, 1.1, 1.2, 1.3 till 1.255. Then 2.0, 2.1, 2.2, 2.3 till 2.255. Again, till when you are going to write, till third and fourth octet reaches 255.255. Then you will move to the second octet and you will increment this 1 to 2. And the series will be 10.2.0.0. So till when you are going to write, till it reaches, the second octet reaches 255, then 255.0.0 till 10.255.255.255. This is how you will get more than 16 million IP addresses. Now guys, all right. Now guys, the first IP address of the network is called as network ID. Okay, if you remember our first example, we required 200 IP addresses, and we have taken class C network, and the network is from 192.168.1.0 till 192.168.1.255. So this is the first IP address of the network, and it is called as network ID or network address. And guys, this network ID we can't configure to any device. The first IP address of network we can't configure. Okay, and it is the first IP address of the network, and in the host portion you will have all zeros. So we have this one host portion here, and it is having 0. And what is the purpose of this network ID? It is reserved for identifying the complete network. What is the meaning of this identifying the complete network? Let us say you are using class A network in your LAN, and if someone asks you what IP addresses you have configured in your network, so are you going to tell like this: we are using 10.0.0.1 IP address, 10.0.0.2, 10.0.0.3, 10.0.0.4? Are you going to tell all the 16 million IP addresses to him? It is not possible. It is possible, but it will take time. So instead of telling the IP addresses, what you will do, you will say we are using 192 dot or 10.0.0.0 network. Okay, so the other person, it will understand that you are using the IP addresses from this network. You can say 192.168.1.0 network we are using. So we will understand you are using 192.168.1.1, 1.2 till 1.254. So this network address is used to identify the complete network, and it can't be assigned to any device in the network. So let us try to assign this network address on my laptop. So guys, it is saying the combination of IP address and subnet mask is invalid. All of the bits in the host address portion of IP address are set to 0. Please enter a valid combination of IP address and subnet mask. So you can see it is not accepting the first IP address because it is saying that in the host portion all zeros are there. And valid IP addresses are assigned to any device in the network. So the IP address, so we have one more reserved address which is called as broadcast address. So the IP addresses between network address and broadcast address, they are called as valid IP address, and we can configure the valid IP addresses to our devices in the network. Then guys, we have broadcast address. Okay, so this broadcast address is the last IP address of the network. Okay, this is the broadcast and all ones in the host portion. So guys, it is having 255. If you convert this 255 into binary numbers, you will get 8 ones. Okay, so 8 ones means all ones in the host portion. We have all ones in the host portion, which means if we have all ones in the host portion, it is a broadcast address and we can't configure the IP address which is having all ones in the host portion. And it is used to send the broadcast message to all the devices in the network. So what is the use? Okay, so let us say we have some computers in our network like 192.168.1.10, 1.20, 1.30, and we have some other computers as well. We have 200 computers in our network, and this computer wants to send one packet to all the devices in the network. It wants to do the broadcasting. So instead of sending one packet to each computer individually, it will send the packet to this broadcast address, to the last IP address. This broadcast address, it will send the packet to all the devices in the network. Okay, so it is used to send the broadcast message to all the devices in the network, and it can't be assigned to any device. So let us try to assign this broadcast IP address to my laptop. One 192.168.1.255. So guys, the combination of IP address and subnet mask is invalid. All of the bits in the host portion of IP address are set to 1. You can see if you convert this 255 into ones, it will become 8 ones, and in the host portion all ones are there, so it will not accept it because it is reserved for the broadcaster. So here we will see what is subnet mask. So when we configure the IP address, you will see one more field here which is called as subnet mask. Let us try to understand what is the use of this subnet mask. So let me show you in my computer as well. It is here. So when we try to configure the IP address manually, and you can see it is having subnet mask and default gateway. So let us try to understand what is the use of this subnet mask. Here, if I say the IP address of my computer is 192.168.1.1. So how will you identify that this IP address is having 3 network portions and 1 host portion? It is a class C IP address. In class C, you have 3 network portion and 1 host portion. So how will you identify? You will see this number, the 192, and 192 belongs to class C, and in class C you have 3 network portion and 1 host portion. So as a human being, by seeing this first octet, we can easily tell that it is having 3 network portions and 1 host portion. But how the computer knows that this IP address is having 3 network portion and 1 host portion? We need to give the subnet mask. So when you configure class C IP address, you will give the subnet mask like this: 255.255.255.0, which means 255 means it is a network portion, and 0 means it is a host portion. So in class C, we have 3 network portion and 1 host portion, and the subnet mask will be 255.255.255.0. So this is the default subnet mask of class C. And in class B, we have 2 network portions and 2 host portions. So you can see, you will write the default subnet mask of class B like this: 255.255.0.0. In class A, you have 1 network portion and 3 host portions. So you will write 255.0.0.0. So what is the use of subnet mask? Subnet mask differentiates the network and host portion. 1 represents network portion, which means 255, and 0 represents the host portion. If you try to configure the IP address from class C, so let me configure the IP address from class C 192.168.1.1, and if I press tab button, it will take the default subnet mask automatically. You can see 255.255.255.0, because this IP address belongs to class C, and the default subnet mask of class C is 255.255.255.0. If I configure the class B IP address, you can see the subnet mask is 255.255.0.0, because class C is having 2 network portions and 2 host portions. If I configure the class A IP address, and if I press tab, it will take the default subnet mask of class A, which is 255.0.0.0. And how to verify, how to check which IP address is configured on your PC? You will use this command, ipconfig. You will go to command prompt and you will type ipconfig. You will get this detail. You will get the IP address 192.168.2.19. You will get the subnet mask, which is 255.255.255.0, and default gateway as well. Let us verify. You will type this command. So you can see the IP address of my Wi-Fi adapter is 192.168.43.87, and subnet mask is 255.255.255.0, and the default gateway is 192.168.43.100. But let us say we need some more information, like what is the DHCP IP address of this PC, and what is the DNS of this PC. So you will use this command, ipconfig/all. So it will give you the additional information. Let us verify. So if you see here, you are getting the DHCP server IP address with this IP config / all, and you will get the DNS server IP address, and you will get the physical address or MAC address, and this is the IP address, this is the subnet mask, and this is the default gateway. And guys, we have private and public IP address. So let us try to understand what is this private and public IP addresses. So imagine we have three organizations using the same network in their LAN. So we have ABC organization, PQR organization, XYZ organization. These three organizations are having their LAN. So ABC is having two computers, and it is connected to switch, and they are communicating with each other. They belong to 1.0 network, and the physical connectivity is there. PQR is having two computers. It is connected to switch. Physical connectivity is there, and the IP addresses to these two PCs are assigned from 1.0 network. So the logical connectivity is also there. So ABC is using 1.0 network. PQR is also using 1.0 network, and we have one more organization, XYZ, and they are also using 1.0 network in their LAN. Okay, so here these three different organizations are using the same network in their LAN, but they are not directly connected. So there is no problem if they use the same network. It will work fine. It will allow these computers to communicate with each other because these three networks are not directly connected with each other. Okay, and the IP addresses which are configured in your LAN, they are called as private IP addresses, because you are using these networks in your private network. That is why it is called as private IP addresses. So till now there is no problem at all. Let us say they are connected. All these three organizations want their computers to get the internet access. So they are all connected to internet, and on internet we have cisco.com server. So let us say this 192.168.1.1 of ABC organization wants to open the Cisco site. Here the source is 192.168.1.1. Destination is 192.168. Sorry, the destination is cisco.com. Okay, so the request will go to this router. From router, the request will go to internet. From internet, the request will go to cisco.com. Cisco.com will see that the request is coming from 192.168.1.1. In this example, we have three 192.168.1.1. So cisco.com will get confused and it won't be able to send the response. Okay, so this is the problem here, where you are trying to access the internet using your private IP addresses. So in this example, we have taken only the three organizations. So all over the world, we have millions of organizations. They are using the same network in their LAN, which means we can't access the internet using your private IP addresses. So what is the solution? The solution is public IP address. So what is this public IP address? Public IP address is a unique IP address. It is like your mobile numbers. So no two mobile phones can have the same mobile number. The same way, no two devices can have the same public IP address. They are the unique IP addresses. So what you will do, you will configure the public IP addresses on each network. So ABC have purchased 1.1.1.1 public IP address. PQR has purchased 2.2.2.2 IP address. XYZ has purchased 3.3.3 IP address. Now again, this 192.168.1.1 of ABC organization wants to access cisco.com. The source is 192.168.1.1. Destination is cisco.com. The request will go to the router. This router, what it will do? It will not send the request with this private IP address. It will replace this private IP address with this public IP address, and the request will go with the public IP address. So this cisco.com will see that the request is coming from 1.1.1.1, which is a public IP address, which is a unique IP address. Then it will send the response back to 1.1.1.1, and this router knows which PC has originated the request, and it will forward the response back to 192.168.1.1 and changing the IP address from this private IP address to public IP address. It is called as NAT, network address translation. Okay. So you are going to, I think we have already covered this LAN in our CCNA class. And the difference between public IP address and private IP address is this public IP address used on public network. If you want to access the internet, you need public IP address, whereas this private IP address used within your LAN or organization. This public IP address is recognized on internet, whereas this private IP address is not recognized on internet. You can't access the internet using private IP address. You need public IP address. It is globally unique. As we have discussed, it is like your mobile number. No two mobile phones can have the same mobile number the same way. No two devices can have the same public IP address. Whereas this private IP address is unique in your LAN. And this public IP address is provided by ISP, Internet Service Provider, whereas this private IP address is provided by the administrator. And you need to pay to get the public IP address, whereas this private IP addresses are for free. So guys, we have some examples of this private and public IP addresses. So if you see, we have the ranges as well. Okay, if you have decided to configure the IP address from class A network, okay, the range of the class A is from 0 to 127. Okay, out of this 0 to 127 networks, there is one network from 10.0.0.0 to 10.255.255.255. These networks are reserved for private IP addressing. You should configure the IP addresses in your LAN from this network if you are using class A. Except these networks, all the other networks are reserved for public IP addressing. If you have decided to configure the IP address in your LAN from class B, okay, the range of this class B is from 128 to 191, and this range is reserved for private IP addressing 172.16.0.02, 172.31.255.255. Except this range, everything is reserved for public IP addressing. If you are configuring the IP addresses in your LAN from class C, the range is from 192 to 223, and out of this 192 to 223, this range from 192.168.0.0 to 192.168.255.255 is reserved for private IP addressing. Except these networks, the other ranges are reserved for public IPs. Okay, so 192.168.1.1, this IP address is falling between 192.168.0.0 to 192.168.255.255. This is the private IP address. Using this address, you can't access the internet. Then we have 203.165.201.30. This IP address is falling here. Okay, so it is a public IP address. Then we have 192.168. It is falling here. It is a private network. So this is how you will identify the IP addresses. And who is providing this IP addresses? This public IP addresses. Who is responsible to manage this public IP addresses? So INA is responsible for allocation of globally unique IP addresses. IANA stands for Internet Assigned Numbers Authority. They are the one who manages the IP addresses. So INA is operated by ICANN. ICANN stands for Internet Corporation for Assigned Names and Numbers. So INA delegates the allocation of, so this is the INA. What this INA will do, it will assign the block of IP addresses to their branches. So INA is having 5 branches like Aprinic, Epinic, Erin, Lacnic, Ripe, and CC. Afrinic, this branch is for Africa region. Epinic, this branch is for Asia Pacific region. Erin is for Canada, USA, and some Caribbean islands. Lacnic is for Latin America and some Caribbean islands. Ripe LCC, it is for Europe, Middle East, and Central Asia. These are the 5 branches. And the correct terminologies of these 5 branches is RIR, Regional Internet Registry. So IANA is having 5 regional internet registries. So it will assign the block of IP addresses to all these RIRs. These RIRs will provide the IP addresses to their ISPs. ISPs will provide the IP address to the end users.